I do call myself an expert in dinosaur studies.
chickens.
Holy cow! We're not even quite ready yet, but thank you for the raid, Gar7. Thank you very, very much. Really appreciate that. I still have a few more things to get ready here, but holy moly. Welcome to Paleontologizing, everyone. It is wonderful to have you here. And, yeah. The raid waits for no one, apparently. Oxyrage, yes, indeed. Hello, everybody. It's good to have you here. Here, my name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. Give me just a couple more minutes here to get ready, but, here, in the meantime, let me play a quick little welcome video for you. Let's find that real quick. Just set up properly. But, how was your stream, Gar7? I hope it was really, really good. Wonderful to have you here. We are going to be going over a ton of fossil news today, so stay tuned for that. I've been a little bit, well, I was under the weather for a while and then really busy. I was a panelist at WonderCon this weekend in Anaheim, California, talking about the confluence of paleontology and popular culture. So, anyway, doing that and a bunch of other stuff. Just been really, really busy. Haven't had an opportunity to really go over too much fossil news lately. But anyway, let me pull up the welcome video, the channel trailer for you to explain what we're all about here. And, well, here you go. My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils. Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs. A limb bone from a new duck-billed dinosaur. I invite you to tune in and experience the adventure of fossil science. Well, there we go, everybody. If this seems interesting to you, please stick around. I've got a few more things that I got to get ready before we can really start off with today's festivities, today's fossil outreach.
Look, you don't have time to put dinosaurs in your dinosaur movie.
Dinosaur! Gigantic dinosaurs attacking our boy! A dinosaur? What?
And you like fossils? You're in the right place, Daniel. Adioke.
We have much to learn about the age of reptiles.
And thank you for the follows. John Athenios, Xhister, Oxyrange, Alf31415, Most Hated Dunlove.
Dinosaurs came in all shapes and sizes.
That's true. We'll be talking about that today as well. Good to have everybody here. Holy cow. Let me play another couple little videos for you. In fact, actually, here, give me a second. Oh, hello. One of my landlords is visiting. Checking in on things, doing a little inspection. But hang on a minute. It's probably something we'll be talking about a little bit today, but anyway, let me play while I'm getting ready here. It's about 8 minutes long. When I was on the news a few years ago, in England, of all places. Take a look at this, and I will be right back. I was a little nervous when I got contacted for this interview. I'm like, isn't GB News kind of a... Don't they have a rather right-wing reputation? So I was kind of geared up for a fight here. It ended up going much, much better than I thought of. Michael Portillo was a real gentleman, and he was all for, you know, protecting the integrity of fossil science. So take a look. And welcome Vasta Tarantula. Thank you for the kind words.
Welcome back.
I'm not really a video game guy, so I'm not really the right person to ask. I have played a few games here on stream, but for the most time, we don't really have time for that. With so much fossil news, interviews with other paleontologists, live fieldwork and stuff like that. That's the sort of thing I tend to focus on a bit more. Anyway,
I will be right back. I leave you here for a minute.
In the world of dinosaur bones, something is out of joint. A skeleton of a Tyrannosaurus rex named Shen was due to be auctioned with appropriate hype in Hong Kong this coming week. Expected to fetch more than £20 million, Shen was abruptly withdrawn from sale by auction house Christie's when doubts emerged over the provenance of parts of the skeleton. The plot thickens as it appears that some of Shen may be replicated from the bones of another T-Rex called Stan. This Jurassic whodunit has serious implications. Globally, millions are made illegally trading bones and fossils, which are diverted from scientists who could study them. David Waterhouse is the Senior Curator of Natural History and Geology at Norfolk Museum and joins us from Norwich. Hello, good to speak to you again.
Yeah, nice to see you, Michael.
And from Northern California, dinosaur paleontologist Danny Anduza, who hosts Paleontologizing, which can be viewed on Twitch. David, first of all, why does it matter that there's an illegal trade? In what way are they diverted from scientists, and why does that matter?
Yeah, I think you know, these are really important things. They're not just art, and I think that's the problem. That's not to downgrade art in any way, but we're picking up scientific information about our environment, the environment in the past. We can learn about our environment in the future. So potentially really important science can be lost if these fossils like T-Rexes and other fossils go straight into the hands of private individuals.
Danny, can you understand why a skeleton could be worth $20 million or pounds or whatever?
Frankly, Michael, I can't. As somebody who's dug up a lot of dinosaurs over the years, I've done a lot of field work in places like Montana and Utah, working with various museums. It doesn't cost very much to dig these things up in the first place. Maybe a few hundred or a few $1,000s to dig up, you know, a handful of bones, like in the Shen specimen. There's really no reason in the world why it should sell for anything over $1 million. Paleontologists like me are flabbergasted every time that happens, and I think it's because the buyers are being misled, as they were in the case of Shen.
Sticking with you, Danny, there was the case of the actor Nicolas Cage, who into his possession there came a skull. Do you want to describe that and tell us what happened about that?
Sure. There's so many of these cases that it's sort of difficult to keep them separate sometimes. But if I recall correctly, this was a Tarbosaurus skull that Nicolas Cage, I guess, purchased at auction, and that had been illegally smuggled out of Mongolia. You know, this country kind of nestled between China and Russia. A wealth of dinosaur fossils from that country, one of the world's greatest, you know, dinosaur fossil fields. Recently, the people of Mongolia have been trying to kind of take hold of their heritage and make sure that fossils from their country are not being illegally exported and sold. That had happened in the case of Nicolas Cage's purchase. And I believe it was seized by Interpol and actually taken back to the country of Mongolia, where it rightfully belongs. So I think it's a perfect example of kind of how shady these deals often are. And if you're trying to buy dinosaur fossils, realize that there's a lot of kind of difficult things going on in terms of morality and in terms of law. These are not smart purchases to make.
David, moving away from this, I think, rather hideous illegal trade, tell us about the proper use of dinosaur bones. Tell me about your passion. When you're given a skeleton, you're given a bone, how do you react to it and what do you do with it?
Yeah, I mean, you know, I've been on T-Rex digs in Montana, which is where both Stan and Shen originally came from, and you know, it's that discovery. I was working for a public institution, so now this T-Rex is on display actually in Los Angeles. and it's that kind of feeling that you're the first person to look at this ever, because there weren't people around when dinosaurs were around, of course. But uncovering something that's 66, 67 million years old, and finding out all that information. And actually, one of the problems with treating skeletons like a sculpture and having it in your foyer of a private company
Medicine's
or
not
a
a
private
science.
house is that it is just a skeleton. If things are excavated properly, you're looking at the whole environment. You're picking up little bits of information from the sediment around, what the environment was like, what other animals were around, and it's just so much more than just a skeleton.
Digging these
It's
bones out of the ground
whole
is a
entire
slow
picture.
process.
And what we do in Norfolk is, because we don't have any dinosaurs here, but we do have mammoths. As you know, it's one of the best places in the world to find mammoth fossils. And we encourage responsible fossil collecting. And in the UK, that's not enshrined in law, as would be if you found, say, an archaeological treasure. If you found gold coins, there's laws in place to look after that, the Treasures Act. So we have to do it kind of ourselves, and it's a little bit, think of it like the Countryside Code. There are certain things, you shouldn't be digging into cliffs, it's dangerous anyway. We've got sites of special scientific interest where you need planning permission to dig in there. But it's also then about sharing your finds. Take it to the local museum. They're not going to take it off you. They might take it for a while to study, and then you get it back. And that's a good way of doing it.
Let me just go back to Danny for a moment. Danny, in the United States, do you have a proper legal environment to protect these bones and fossils?
It's a little bit complicated here in the United States. Unfortunately, if a fossil is found on private land, unfortunately from the perspective of paleontologists, then it's the property of the landowner, and they can do with it what they please. They could donate to a museum, or they could give it to their dog to chew on. Regardless of the scientific importance of whatever the find might be, ultimately it belongs to the landowner. If it's from private land, if it's from public land, the sorts of lands that I work with, Bureau of Land Management land, state lands, then it belongs to the people of the United States, and it needs to be held in the public trust, held in perpetuity so that scientists can study it and the public can enjoy it. And that's what paleontologists like us think should happen for every scientifically important fossil. They're a benefit to all of humanity. They're part of our collective natural heritage. They belong in a museum.
Danny Anduza and Professor David Waterhouse, happy digging to you both. Thank you very much for being on GB News.
It's been a pleasure.
Well,
thank you.
Leonardo da Vinci drew it, H.G. Wells described it, and Winston Churchill ordered it to be built.
Anywho, I don't know what the answer to that riddle is. You can click the link that I put there in the chat if you want to figure that out. Thank you, Mommy Does.
Remember, dinosaurs and human beings lived on the Earth at the same time.
What?
What, like the Flintstones?
Mommy Does, thank you so much for the 47 months of support. I really appreciate that. At tier 2, no less. Thank you for that. Anyway, good to have everybody here. We're already getting some landlord interruptions. But, it's so good to see everybody on this beautiful Tuesday. It is March 31st, 2026. And, we're going to be doing some paleontologizing. Sweetie Pie, watch out for the camera. We're going to be going over a lot of fossil news today, so I'm glad you're here. We're going to be trying to catch up on some of the stuff that we've missed over the past, 3-4 weeks? So we're introducing a new thing that I call the Wheel of Fossil News. So we'll be getting into that in a little bit. But, yeah. Osteraptor says, was that an Indiana Jones reference? What?
That belongs in a museum!
Oh, definitely not, no. Welcome back, Osteraptor. It's good to see you. Yeah. Better get Chairman Meow in there. There you go, Ordospacist. Yeah, welcome back. Good to see you. Welcome back to everybody. Again, if you're new here, my name is Danny Anduza. I'm a dinosaur paleontologist here on Twitch, trying to do some good old-fashioned science outreach. As a paleontologist, I've been lucky enough to be able to pursue my passion. I've always been interested in fossils, dinosaurs in particular. And I've been incredibly lucky to be able to turn that into a career. Nowadays, my full-time job is literally streaming. This is how I make my living. This is how I pay the bills, how I fund my research and field work and travel. And it's honestly a dream come true to be able to share the world of fossil science with all of you. Whether we're here in my office, or whether we're out in the Badlands of Montana or Wyoming or Utah, digging up fossils and collecting data. The whole point of these streams is to show you firsthand what fossil science is really like. To give you an inside perspective into these things, to help you try and appreciate the history of life on Earth and our own place in it, how we learn about it, why it's important, why an understanding of paleontology can improve your daily life. So that's what I'm all about. Today we're going to be going over some new scientific papers that I'm very excited about, and doing a lot of Q&A. Everybody has questions about dinosaurs, about extinction, about evolution, about the history of life on Earth. I don't want you to be shy with those questions. I want you to ask them. And if I've missed some earlier, then please retype them, because I'm looking at the chat more intently now. And we can talk about that. We'll also be doing some Metazoa, our daily animal guessing game using an evolutionary family tree. All kinds of good stuff like that. So, I'm glad you're here. And apologies for these fuzzy mammals. I've got two of them in the office right now. One of them is out of view. But they're my landlords here, and they kind of have the run of the place. And I'm so hesitant to shoo them off the desk. Huh. What are you up to, sweetie pie? Yeah. Max Devlin's got a question. Is it known if Spinosaurus hunted in saltwater or freshwater, or did it hunt in both? So we know that Spinosaurids lived near the coast. The Spinosauridae as a group, these long-snouted, fish-eating dinosaurs, these guys had a surprisingly short reign on Earth. Spinosaurids first really show up in the early Cretaceous period, and then by the beginning of the late Cretaceous, they're already extinct. They're gone. So they weren't around for very long, and part of that might be due to global sea levels. So Spinosaurids first show up around this time, when the continents looked like this on Earth.
World, 225 million years ago.
And holy cow.
Of the Mesozoic era.
Nerduino, thank you for those 35 months of support. If any of you are not yet following Nerduino, you're missing out. Nerduino is a fellow scientist here on Twitch, former NASA scientist, current astronomer. He can teach you all about what's going on outside of our atmosphere. I'm more of an Earth guy. Nerduino is kind of some Earth, but everything else too. We'll give him a follow if this is news to you. What are you doing back there? I think she might be plotting some mischief. We'll keep an eye on her. But yeah, this is roughly what our planet looked like about 120 million years ago. This is kind of the heyday of the Spinosaurids. And so at the time, sea levels were a bit higher than they are today. And coastline is kind of the area where we normally find Spinosaurid fossils, whether we're talking about Baryonyx or Suchomimus or Ichthyovenator. These critters, you know, they kind of inhabited these areas that are on the margins between the ocean and the land. By about 105 million years ago, you've got some of the biggest Spinosaurids existing here in between, like in this kind of fresh, shallow seaway between, when I say fresh, I mean newly formed. It was saltwater. But between South America and Africa, this was just like a haven for these critters. And so we think that they were capable of going in between freshwater and saltwater. You know, think about you know, they're probably, in my opinion, these guys are not like active pursuit predators. They're not hunting subaqueously. They're not like, here, this I think is wrong. This right here. I don't think they're doing this, where they're like swimming under the water like a killer whale or something. No. These are guys who are wading along the shoreline like a heron, or maybe like a crocodile. They're maybe dipping under the water for a short amount of time, but they kind of, you know, these are not like open ocean predators, if that makes sense. They need to be near the coastline, or going up into lakes and rivers far inland, but they're shallow water predators. Really cool critters, Spinosaurids. And we know that they were eating these gigantic fishes at the time. Enormous sawfish like chondrichthyan fishes, huge coelacanths, and giant lungfish. They're such cool critters, and I actually have a paper that I really need to get published sometime soon on the feeding ecology of these animals. They're so cool. Aren't they, Mini Pie? Yeah. Anyhow. But yeah. And Mayor of Space. Oh, this is under your jurisdiction, isn't it? Tomorrow some of our Earth guys are going to start their journey to our closest heavenly body. Is the moon mission thing, is that actually happening? I thought that was canceled. It's crazy, like, how little attention that's been getting lately. Like, this is kind of the first I'm hearing about that. Artemis 2 is tomorrow at 3:20. Oh, interesting. It's a moon flyby. Well, hope it goes okay. NASA has certainly been kind of gutted recently. There's a bunch of high-profile cases of, like, long-standing NASA scientists who are quitting. They're like, yeah, this place is... The current presidential administration is kind of intent on dismantling NASA. So I'm honestly really surprised that's going through. I wish him the best of luck. I hope it's successful. Yeah. Anywho, good to see everybody here. And don't tell Sweetie Pie, my other landlord, but Mini Pie here, she's gonna get some treats. Yeah, aren't you? Yeah, we gotta pay the rent. We gotta pay the rent. Oh, look at that. Anyway, if there were other questions that I missed, please let me know. I'm a little thrown off kilter by that sudden early raid today. But if you had another pressing question, a burning query, don't let me overlook it. Just, I promise you're not spamming. Just put it again into the chat. Anyhow, yeah. Did Nerduino say something? Lots of overlap. Have you heard this admin is now the biggest supporter of NASA after their cuts were rejected by Congress? Oh, wait. Holy cow, were those cuts rejected? If so, that's really exciting. That's really exciting. Holy cow. Anyhow, yeah. Alexander Morrison, this is the ilium and part of the pubis, and then the femur of Sarcosaurus, which, if I remember correctly, is probably a coelophysoid dinosaur, early theropod from Europe? Let's look that up in a second. But yeah. No, it's definitely a Saurischian. Yeah. Sarcosaurus. There we go. Yeah, neotheropod from England, from the early Jurassic. Yeah, so we don't have very much from this animal. And the specimen here on display is actually the one at the top there. So you can see that there is the ilium, part of the pubis, and then one of those femurs. So it's the one at the top. That's right here. 3D printed for your edification. And, yeah. And Gravity will be getting into fossil news in just a little bit. We've got a brand new tool for that. The Paleontologizing Wheel of Fossil News. Lots of stuff to cover, and we're going to be picking it at random. So, stay tuned for that. We'll be doing that in a little bit after we take care of some other things. So, yeah. Oh, speaking of 3D printing, I need to go get that 3D printer fired up and print another one of these. Doing more of these leatherback turtle bobbleheads. Because why not? So let me go get that set up. We'll get one of those done live on stream. There we go. Excellent. I need to count up how many of these I have so far, but this is a critter that'll probably show up multiple times today in our fossil news segment. Second, let me find that here. Yeah, I'm seeing the wheel a lot. I assume we'll see how it goes today, Gravity. We'll see how it goes. If people like it, if it works well. It is kind of our trial run for that today. But here we go. Take a look at this mysterious, some might say legendary animal. What in the world is that? What the heck? Russian submarine? I don't know. Maybe it's swamp gas, Claire Burr. Is it a pod of dolphins? Here. Let me play it with the sound on.
This is the coolest thing.
And you see how much the tone changes? I love this. This makes me so happy.
This is the coolest thing I've ever seen.
I was out with my other friend and we were just about to start fishing and this giant head pops up behind us. And at first I thought it was a sea lion. The person I was with, he was like, that is not a sea lion, that is a sea turtle. We dropped everything. I just grabbed my phone as fast as I could.
The world's largest turtle.
I didn't know that sea turtles could get that big. He was just...
This is a turtle that can weigh as much as a Harley-Davidson motorcycle. A turtle! They can survive and thrive in waters that would kill you and me. We would freeze to death, and here's a turtle swimming around in that water.
Cruising along the surface, and...
Not this water here, up in British Columbia, but like off the Aleutian Islands of Alaska, or the North Sea, north of Norway. a turtle swimming around in
Just
there,
kind of gracing
living
us
its
with
best
his
life.
presence. He looked very happy. I have seen some amazing animals. This is number 1. I didn't know it was on my bucket list, but it clearly was.
Oh my god.
The last one I know was seen at that lodge was in 2008. They have a boat named after it, Leatherback. The sightings are so rare. It truly just is so magical for me, and it just makes me appreciate things so much in our waters. I just feel so special.
Fun fact, we call them ancient. They've been around this planet for 100 million years. Less
Give or
fun
take,
fact, since 2003, they've been endangered. Rare sighting indeed.
Oh, State of the World Sea Turtles. Thank you, Lordy. Maybe we should add that to our... Come on, YouTube. Pause. Pause. Goodness. You press the button 4 times and it doesn't work. Anyway, absolutely incredible animals, leatherback turtles. I've been obsessed with these creatures since I got to go on a trip to Puerto Rico last May to see the land of my ancestors. And every beach that I went to, leatherback turtle nests, just all over the place. It was incredible. I'd always known about these animals. If you're a paleontologist, you hear about leatherback turtles because they are just remarkable creatures. But like every beach that I went to, leatherback turtle nests. Just bonkers. This creature that like had legendary status in my mind. They were just here like a few nights before. That's so crazy. They felt so close to home. And I realized that I could get involved with their research and conservation. Just one of the most extraordinary creatures on the planet. They are at severe risk of extinction. Their populations have declined around the world by over 90% just within the last few decades. We could lose them like that. So they really need our help, and they've been around since the time of the dinosaurs. Just an absolutely superlative animal. I'm very excited to be getting more involved with these critters. I'm going to be going on a special trip in late May, kind of centered around leatherback turtles. So I am very, very excited for that, and I hope you stay tuned because we're going to be streaming as much as possible from there. Hopefully I'll be able to show you some live leatherbacks. Likely some hatchlings. Maybe even a nesting female, an adult. We'll have to see. I need to send some more emails out about that this week and start talking with some turtle people. Yeah. Kuda says that almost looks fake. Holy moly. I know, right? I mean, part of it is the camera angle, that it's like low down. So it's not really as tall as those people, but it is pretty enormous. They can weigh close to 2,000 pounds. They can be nearly 10 feet, so like just shy of 3 meters from flipper tip to flipper tip. They are enormous animals. Again, the world's largest living turtle. Just extraordinary creatures. Really amazing. And they are unique among turtles. In fact, it's still kind of unclear how closely related they are to other sea turtles. So much about them remains mysterious. But they're just incredibly cool. So I'm going to be doing everything I can to get the word out about these animals, get people excited about them. And they will be showing up a couple times today, I think, on our Wheel of News. So stay tuned for that. Mirror Spaces, even Michael Phelps doesn't have a wingspan like that? No. In fact, this is a turtle that is faster than Michael Phelps. I think his top speed is something like... What is it? Like 9 miles an hour in the water? Something like that? More than 5, I think. I don't think he's given himself enough credit. But he's, yeah. One of the world's fastest swimmers. He's been called a freak of nature. Leatherback turtles can swim like 2 or 3 times faster than he can. I think they get up to like 18 miles per hour in the water. Just astonishing. Truly amazing. Alright, maybe I can find some footage of them swimming. I've got a special playlist right here that I can share with you with a bunch of curated videos on leatherbacks. Here, take a look at this. Oh, and hang on. Sammy Keene, thank you for the 28 months of support. I really appreciate that. Not sure why our alerts are currently borked, but I appreciate you keeping me here online for the past 28 months.
The extinction of dinosaurs is the absolute prerequisite to the evolution of large mammals and to our own existence, for that matter.
In Utah, Arakeshi, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. And Voss the Tarantula, hey, holy moly. Thank you for subscribing. That's a first-time sub right there. A recurring sub, no less.
Let's protect our fossils, because if they're removed, America loses them forever.
Voss, thank you for that. Really appreciate it. Welcome to the community. Enjoy those emotes, which are now yours to use as you see fit, including some leatherback turtle emotes.
I like turtles.
Pretty awesome. Leatherback turtles are here. Trying to find some footage of a leatherback swimming, because they're, when you think of turtles, you often don't think of the words grace and beauty and speed. But holy moly, are they at home in the water? Check this out.
Fishing, and we saw some really cool
We went out fishing.
stuff. First we saw dolphins, so we got out the GoPro to film them. Then we spotted a big fish, but it wasn't a shark. It was a
shark.
Huge sunfish. They look really weird because they have no tail.
And then, oh, it gets better. Holy cow, it gets
But
better.
next, we saw something even bigger. At first we didn't know what it was, so we approached carefully and put the GoPro underwater to try and get some footage.
Holy cow. Look at that.
And then it came up, and we saw what it was.
It's a giant turtle!
It's a giant turtle!
Oh, it's massive!
Is it a turtle?
Massive. Massive turtle!
There it is there!
Holy cow.
Oh, just get the footage of it. It's a massive leatherback. Oh!
Just astonishing.
Leatherback turtles are the biggest of all turtles.
He's right.
They can grow up to 3 meters long, and their big pec fins that they swim with can grow over 2 meters long.
Yeah, almost 3.
This one is really big, definitely
Look at this,
over
Bryce,
2
look at this.
meters. And when it came up for air, it had a really big head, even bigger than my dad's head.
Like, I'm sorry, what did he say? He had a really big head. He had a really big head. Really big head, even bigger than my dad's head.
Really big head, even bigger than my dad's head.
By the way, that's what I got on the wall today, is a leatherback turtle skull. This is a 3D print of Dermot Kelly's Coriacea's skull, and it is bigger than my skull, for sure.
Yeah, I can see the light. Yeah, he's right here, he's right here.
Amazing. Such cool footage. They did such a good job with this. I know it sounds like I'm making fun of them. Good on ya, I would say. This is such a cool video. They did such a good job.
It's so big you'd think it's fake. I didn't even know there were turtles so big. Are you recording?
Oh, bro, look at that. Look at that, bro. Bro, I've never seen such a big leatherback ever.
Leatherback turtles are endangered, so we're really lucky to see one up close.
Very lucky. Holy cow, like a once-in-a-lifetime experience. Incredibly cool. How neat is that? You know? Oh, and Linus is female. Here, let's look. Who can tell me? Well, no, I'm not going to ask that because we're going to get some snarky and possibly not PG-rated answers. The way that you can tell the difference between a male and a female adult leatherback turtle, like with just about every turtle, you look at the tail. Males have long tails. They actually use it as like a clasping implement during mating. The females have a shorter tail. So if we're talking about leatherbacks, I have a model of a leatherback right here. There it is. Yeah. So it's 3D printed, but it's painted to look like it's bronze. Anyway, this is the end of their carapace. So this is their shell. Underneath is the tail. So there's the tail right there. In females, the tail barely goes to the end of what we call the pygal process, which is the posterior end, the back of the carapace, the top shell. In males, it's much longer. So, here, I can show you Ricky. Here is a male leatherback turtle who was brought aboard this research vessel for tagging and collecting data to try and keep tabs on the Pacific population. This population is declining by something like 5 to 6% per year. They're in desperate need of our help. Continued protection. But I wanted to show you the tail. Here we go. Here's that same leatherback. This is from last fall. And look how much longer the tail is on a male. So in a female, the tail would just basically go just past the end of the pygal process here. And a male, the tail is much longer. So in the case of this leatherback,
look at that, bro. Bro, I've never seen such a big leatherback.
See the tail.
Leatherback turtles are endangered, so we're really lucky to see one up close.
Very lucky.
Whoa.
Yeah, that looks like a female. I'm not seeing a long, prominent tail, so.
Woo, there we go.
He's a Shayla, you might say.
Put it to that, Butters. Go, pro.
Awesome. Here is a oh, nope. Stop it. Come on, YouTube. Here's a link to that video there, if you'd like to take a look or give it a thumbs up. And again, that's in the Leatherbacks playlist that I put together, which you are welcomed to take a look at, bookmark, watch these videos, all that good stuff. Here's a link to that playlist. Anywho, yeah. And put another cool fact about these turtles: leatherbacks have a slight top speed advantage over crocodilians. Top speed. Oh, interesting. They are the world's fastest non-avian reptile. So out of all of the reptiles in the world alive today, they're the fastest, except for birds. Birds are a kind of reptile. That might be news to some of the new folks here, but birds trace their ancestry back to the dinosaurs. Birds are a kind of dinosaur. And dinosaurs are a kind of reptile. The reptiles start right here. So we can follow this up to get to the dinosaurs. Birds are a kind of dinosaur and hence a kind of reptile. turtles are over here. In fact, they should actually probably be closer to over here next to the crocs. This is kind of an older diagram. But, yeah. Cool to think about. Excuse me. Good stuff. Before I forget, let's post that I am live on Blue Sky. And then we'll take a quick little image and put that on there, too. There we go. Beautiful. Holy cow, it's 2 o'clock already? Nuts. Here you go, Mayor of Space. I don't know, fly casual. Yeah. Yes. Take a screenshot. Paste it in Paint. We'll see if that's any good. I could do better than that. There we go. Better. We'll use that. There we go. Save as. Oh, I like that my leatherback necklace is visible in that screenshot, too. I gotta find my Z-Cold necklace. It has since gone missing when I got back from Anaheim the other day. But it'll turn up. I know it came home with me. There we are. And you know what? Let's take another screenshot of the Wheel of News, shall we? There. And we'll use the snip tool. Excellent. Today's Paleontology Twitch stream. Let's catch up on some of the paleo/natural history discoveries. Join us at twitch.tv/Paleontologizing. Life-sized leatherback turtle skull and Sarcosaurus pelvis and sundry framed scientific diagrams on the wall behind me. Good enough. And of the Wheel of Fossil News. Featuring 3, 4, 5, 6, 7, 8, 9. About 20 natural history news stories on a colorful wheel, which I won't bother typing out because it would take too long. Apologizing, no typos detected. Looks like we're good.
Hold on to your butts.
Let's post it. Anyhow. Here is a link to that post if you'd like to interact with it. There you go. If the vinyl acetate glue use needed something like that for a project. Oh, yeah, Elias, different kinds of polyvinyl acetate glue. There's a few. Oh man. We should give a shout out to Fossil Preparator, who hopefully will start streaming again on Twitch after he recently purchased a house with his partner. He and she hopefully have moved in already to that place. But yeah, he's a fossil preparator, so one of the people whose jobs it is to clean fossils in the lab. And a lot of that involves using a lot of glue. There's Akiko, who's a professional fossil preparator in Chicago.
Fossils, because if they're removed, America loses them forever.
Rhea Forrest, thank you for the prime. I really appreciate that. Thank you, thank you. So people like Akiko here, she's super cool. I've met her on a number of occasions now. Yeah. Scott Madsen. People like that. Like, their job is to chip away the rock from fossils in the laboratory and also apply glue to them to keep them from crumbling. You do this in the laboratory and you do this in the field too. When you first find a fossil, especially if it's a little crumbly, you apply a lot of glue to it. And so some of those are going to be Bootvar B76 is what I've used in the past. This is a kind of glue that, it's plastic. So you take the plastic beads in here and you dissolve them in acetone, basically like nail polish remover. So that dissolves the plastic, and then you keep it in a spot, in a sealed container. Because once you expose it to the air, the acetone, the liquid part, evaporates away, and it leaves the plastic embedded within whatever the liquid it's soaked into. So you pour this or brush it onto or apply it with an eyedropper or a mustard bottle onto the surface of a fossil bone. It seeps in, and then, as it dries, the acetone evaporates away, leaves the plastic inside. It's we call a penetrant stabilizer. Excuse me. Bootvar B76 is one of these different kinds that we use in the field. There's also B72. Also, we call it paraloid. And then there's also Vinac is another brand name. In different preparators, different museums, different field crews, they will have different preferences. Slightly different chemical compositions are good for different things, and everybody's got, like I said, their own preference, you know? Some people swear by this one and they can't stand that one. Oh, it's too gummy. Oh, it doesn't react well with the heat. Or, you know, it's not shelf stable enough, or whatever. Certain ones are better for certain circumstances, and I'm a little bit convinced that some of this is just like pointless Ford-Chevy rivalry, that kind of thing. Team sports. And part of it is like real, actual, some things are better for some applications than other things. But I don't really have a horse in that fight. I don't have strong opinions about this. I use whatever I'm handed when I'm in the field or in the lab. I don't know enough about this kind of thing to have strong opinions. But yeah. Anyway, I hope that's helpful. Yeah. Oh, and then there's other things like the actual adhesive glue, Paleo Bond, is the one that I know has a good reputation. So instead of using like super glue or something, Paleo Bond is it's a purpose-built fossil adhesive. It's not a penetrant stabilizer, but something you actually use for sticking different bits of fossil bone together if they break. It's supposed to be archival quality. It's museum grade. It's good stuff. It's not cheap, but it's good. So yeah. Hope that makes sense. Like Blockmans. There you go, Steely Dan. Yeah. Yeah. And there you go, Illyspit. I'm glad you're getting into Prehistoric Planet. Very nice. It's a great series. It really is. Universally beloved, I think, by nearly universally beloved by paleontologists. Ready? We're gonna do Metazoa here in a minute, then we'll get into fossil news. Two folks were asking if there was an orca analog alive with Megalodon. Any ideas? A big odontocete whale? I don't know. I don't know enough about that kind of thing. But what we can do is we can look at some of the faunal lists for some of the geological formations that Megalodon occurs in. And we'll see if there's something orca-ish in there. Maybe like the Parissima Formation? So this is here in coastal California. Late Miocene to late Pliocene. I think this is around the time of Megalodon. And this is just a stub. There's no faunal list. Maybe Darktooth Hill? Yeah, Temblor Formation. Do they have Ototus Megalodon in here? Sand Tiger Shark. Yeah, oh, Carcarocles Megalodon, they're calling it. Okay, what kinds of whales do we got? Alodesmus, Myotaperus, pygmy sperm whale, walrus. I don't know if there was like an orca type critter in this formation. What we can do is talk about killer whales, talk about orcas, look at taxonomy. Huh. Orcas might be a more recent thing. Fossil evidence of Orcinus species occurred in a temporal range of 3.6 million till the present day. Okay. Orcinus Setoniensis is from the late Pliocene and early Pleistocene, Italy to England. Smaller than a modern killer whale. 4 meters long, 13 feet. Yeah, so orcas might be like your modern killer whales might be a recent phenomenon. Yeah. That's my guess. Again, I am not an expert on this. If you really need to ask somebody, you know, talk to a whale paleontologist or a whaleontologist, as they sometimes call themselves. Bobby Bosenecker, a friend of mine, might be a person to ask about this. He studies fossil whales and also fossil sharks, fossil seals, sea lions, otters, all kinds of critters like that. Yeah. He also does really cool art. Here's a watercolor that he did of a whale skull. Really nice. Yeah. And there you go, Grab Nerd. Hey, welcome to Paleontologizing. Good to have you here. Why don't we do some metazoa before I forget, and then we'll have more time to do fossil news here. We're already almost an hour into the stream, so, no, over an hour into the stream. So, let's start our daily animal guessing challenge, metazoa. This is always a lot of fun, and it's an excellent opportunity, an excuse even, to talk phylogeny. Oh, and Calvert Formation vertebrates. There you go, Grabnerd. Yeah, that would help. It sounds like you're the right place, Grabnerd. Welcome. So pleased to see people who know a thing or two about natural history here in the chat. This is my excuse to talk about phylogeny. Just about every stream. This is kind of the fundamental unifying principle underneath all of biology. This idea of evolution and common descent. As far as we know, from every line of evidence that we have, all living things on our planet can be placed on one grand tree of life like this. All life on our planet is related. Everything has DNA and has shared common bits of morphology. That's because everything evolved from a common ancestor. If you were to go back in time about 3 or 4 billion years, you might encounter that last universal common ancestor. The single-celled life form that gave rise to the wild diversity of life that we have today. Everything from ladybugs to kelp to quinoa to octopus to you and me. We're all related. Let's find Homo sapiens on here. Zoom in over here. Here we are, nestled among the African great apes. Like the bonobos and the chimps, our closest living relatives, and outside of them, gorillas. And then going a bit further back, we rendezvous with the orangutans. Further back from that, the other old world monkeys and apes. And then the monkeys and apes. Haplorhines, primates. And then we also link up the tree shrews and critters like that. And then with the rodents and their relatives. And you keep going further and further out. Keep doing this until you get to the dawn of life on Earth. Pretty cool how this works. Anyway, we could use this knowledge and this understanding for this challenge here, metazoa. We've got a mystery animal each and every day. We have to try and figure out what it is in 20 guesses or fewer. So luckily it's not all life, it's just animals. So already we only have to deal with about 1.4 million species. Not that many, you know? 20 guesses. We can figure it out, right? Oh, good luck with your meeting, Petrodactylus. Excuse me. Yeah. Yeah. Let's begin.
Hold on to your butts.
The way that this works is, it's a lot like that game Wordle that you've probably heard people talk about, or maybe you've played it yourself. But instead of just trying to guess a word, there is a mystery animal to figure out. So you take a guess at first, and it'll show you the most recent common ancestor between your guess and the mystery animal. I think maybe when in Rome or when in Duckburg. Maybe we'll start with the duck. Why not? Okay. Our critter is not a duck, but it is a bilaterian. Let me show you. Duck. So that's Anis Bladyrhynchus, the mallard. Very much not a duck. No, but it, well, yeah. There's a duck there. We guessed duck, and Metazoa said, nope. Best I can do for you today is bilateria. Let's zoom out to there. We know it's a bilaterally symmetrical animal, at least. I think this might be the majority of animal species. But it did cut out a lot. This is true. This is true. Bilaterally symmetrical animals are here. We started off with 1.4 million species. We're down to 1.399. But, this tells us more than you would think. We guessed duck. It says nope, it is a bilaterian, which tells us... I know for a fact Metazoa doesn't have any of these critters in it, so we can ignore that branch. We know it's some kind of nephrozoan. But let's think. We guessed duck. And ducks are a kind of deuterostome. This is all of the vertebrates and the echinoderms and the tunicates and things like that. We know it can't be a deuterostome because it didn't say deuterostoma. It says you got to go out broader. Nephrozoa. So we know it's not a deuterostome. It's got to be a protostome. This is all of the arthropods and mollusks and their relatives. I'm going to go with a beetle here just because there's a lot of beetle species. They're very speciose group, the Coleoptera. Let's try, say... We did this yesterday, but we'll do it again. Dung beetle. We'll see if it's a kind of beetle. It's not a beetle, but it is an insect. A neopteran insect. This includes most of the winged insects. Modern wing-folding insects. Here we go, Neoptera. But this also tells us more information than you would guess. Beetles are over here. We know it's not going to be part of this clade. Unless they didn't program this correctly. There's always a chance that, like... There's also a chance that the trees don't necessarily agree on the details between Metazoa and Onezoom, but... Anyway, I'm guessing it's something more primitive, more basal than Coleoptera. It could be a flaw. Well, no, because it's not a holometabolin. We know it has this clade. We had this yesterday. It's got to be something more ancient. More early divergent. I doubt it's going to be a thrip, because I don't think Metazoa has thrips. Let's try. No, they don't. It could be something like a cicada. They do have cicadas. Or it could be something more basal than that. A grasshopper, a cricket, a katydid. phasmid, a cockroach. I met a cockroach on Saturday. Let's try cockroach and see if that gets us any closer.
Hold on to your butts.
That's it! Holy cow! Not too shabby. 3 guesses. Yes! Yes! Proud of that. All right. Well, well, well. Shoot, let's share that on Metazoo, or on Blue Sky, shall we? Ha ha ha. All right. Proud of this one. Let's do arm flexion. There we go. Excellent. Yeah. So there, if you know a thing or two about phylogenetic trees, about how we portray how different critters are related to one another like this, you know a thing or two about evolution and about the relationships between different organisms, you can make games like this a lot easier. And likewise, or maybe conversely, practicing games like this help you become a better tree thinker, thinking in terms of evolutionary family trees. So, game Metazoo, I really recommend it to anybody who wants to learn about how different animals are related to one another. It's a lot of fun. And I don't think I've ever seen a cockroach here in the UK. Interesting, Max Devlin. They are famously susceptible to cold. Let's see if we can find a video on these critters. I like to do this every time we play Metazoo. Good excuse to talk about different animals. I was hoping maybe Animal Logic or Animal Fact Files have a video. Maybe not. Oh no, there we go. Excellent. Here. Beautiful. Love this channel on YouTube. They do such good work.
Remember when we talked about termites and mentioned that they're related to cockroaches? Well,
Yep.
now we can talk about these termite relatives.
So again, yeah, cockroaches over here are relatives of termites. There's the roaches there, Blatodia, and they are related to the termites. Hang on. Yeah, they're closer than I thought. There you go. There's the termites, and yeah, shoot. I guess termites, strictly speaking, they're part of the group that roaches roaches give their name to. So they are. I guess you could say that, strictly speaking, termites are a kind of cockroach. Sort of.
Remember when we talked about termites and mentioned that they're related to cockroaches? Well, now we can talk about these termite relatives. Cockroaches and termites belong to the same order. It's believed there are somewhere around 4,000 living cockroach species, give or take a few hundred. Out of those 4,000 species, only a few dozen are the ones that we label pests. The other 3,950 are just doing their own thing on their own turf.
So, that's interesting. There's roughly speaking, there's about as many species of termite, or excuse me, roughly speaking, there's about as many species of cockroach as there are species of mammal. That's nuts, you know? Very speciose group. Today's Metazoo, it took me 3 guesses. Me too, Petrodactylus. Well done. And the Golganek says, why are they showing an isopod? That was not an isopod. That was a kind of cockroach that happens to superficially resemble an isopod. I'll show you. It's got a separate head and everything, and fewer legs. This is a cockroach here. It's got 6 legs, unlike an isopod, which has many more. Isopods have got a bunch of legs. Yeah. Certainly more than 6. This one's got 6 here. And you see it's got a separate head?
It's believed there are somewhere around 4,000 living cockroach species.
See how the head kind of descends like this? Different from an isopod. Yeah, even though the shell in the back looks a lot like an isopod. Carapace, I guess you could say. Exoskeleton. I don't know if it's called a carapace. Let's look it up. Isopod diagram. I'm not seeing the word carapace. Not like on a turtle. Nope, there it is. Yeah, carapace. Okay, it is called a carapace then. Cool. I'm glad I looked that up. I know we go off on these tangents like this, but often if we do, it's because I want to teach you something or I want to learn something myself. Let's continue.
Species, give or take a few hundred. Out of those 4,000 species, only a few dozen are the ones that we label pests. The other 3,950 are just doing their own thing on their own turf.
By the way, Golganek, can I just say, earnestly, I appreciate that you didn't get upset when I tried to correct you on something. I love that about you, Golganek. It's the mark of an emotionally well-adjusted person and a good learner when you can say something that might be mistaken about, might not be true, and somebody corrects you and you go, oh, cool. I just learned something. I work hard to do that myself. And like if somebody in the chat corrects me about something, I try and be really gracious about that and grateful. Because, you know, nobody knows everything. In fact, everybody knows almost nothing in the grand scheme of things. The more you can learn, the better. And when you learn something new, when you learn that something you assumed or thought turns out to be incorrect, it's cool when you get to learn something like that, you know? So, appreciate that, Golden. We don't know what we don't know. It's true, Claire. Well, sometimes we do know what we don't know, but a lot of things we don't even know that we don't know. No, I don't know everything, damn the BC man. Definitely not. And I'm glad I don't, you know? Like, I'm glad there's still so many things out there to learn. That's one of the most exciting and coolest things about paleontology. Is that we're always learning new things all the time. There's so many new discoveries out there yet to be made. It never stops. And that's exciting. When there are mysteries out there waiting to be solved. It's the sort of thing that I get jazzed about, you know? Anywho. Back to this.
Turf. The ones that are considered pests are labeled as such because they may be able to pass on bacteria to us from the food they eat, but in nature they act as decomposers. Cockroaches eat basically anything. They're the epitome of omnivores. They eat plant material like rotting fruit as well as paper, and they also eat animal material such as decaying flesh and bat poop. In turn, cockroaches are eaten by other arthropods like wasps, as well as birds, frogs, lizards, rats, and more. Cockroaches are generally oval in shape, though some, like sand cockroaches, may look a little more circular. They have long, laid-back antennae and chewing mouthparts. Cockroach heads are bent downwards, and are typically covered by a plate called the pronotum. Some species may come with wings, others have partial wings, and some don't have any wings at all, such as females in certain species. They don't usually use their wings to escape. Cockroaches are made for running and scuttle away at the sign of danger. They detect this danger via sensory organs on their rears that pick up vibrations around them. Cockroaches generally prefer the dark and hide under logs, in leaf litter, or in the crevices of caves during the day. They are most abundant in tropical and subtropical areas, but they can be found worldwide with the exception of polar regions. Sorry again, Antarctica. Though most people associate cockroaches with human settlements, the vast majority of them are found outside our enclosed spaces. There are cave cockroaches, some who live with ants, sand cockroaches, and others who are just happy living on the forest floor.
And there are some who live in the mini fridge of a cheap motel that you stay at in Anaheim, California, when you're a panelist on a paleontology panel at WonderCon 2026. I should have taken a picture. Super 8 Roach? No, I couldn't afford the Super 8, Claire Burr. I had to stay at the Super 7. Not a joke.
Cockroaches undergo incomplete metamorphosis, so the babies hatch.
And Dan the BC Man wants to know, are they related to silverfish? Great question. I know silverfish are not related to fish, but where are silverfish? Silverfish here. So cockroaches and silverfish, not close relatives at all. It doesn't have a date on when they diverged, but this would have been way back in probably the Carboniferous or earlier. So they probably split probably 350 million years ago or earlier. So yeah. Yeah. And Vasta Tarantulas is not the Super 7. No, literally. Super 7 Motel. That's where I stayed over the weekend. And there you go, Cacklin. Yes, indeed. Good ears. Yeah. Anywho. Yeah, cockroaches are far more derived. There you go, Starby. Yeah. What if the poor scientist had fused with a cockroach instead of a fly? Well, I mean, I actually haven't seen that movie. Was it Cronenberg's The Fly? I haven't seen it. But yeah. Anyhow. I don't know how different it would have been.
From their eggs as smaller versions of the adults. These are called nymphs. Female cockroaches usually develop an egg case called an ootheca. There are a few ways a female cockroach may handle her ootheca. In some species, the female retains the ootheca in her body and thus gives birth to live young once they've hatched inside of her. This is similar to the hissing cockroaches we've talked about previously. A female cockroach may also hold the ootheca on her rear, giving her rump an extended appearance. She may also drop it and leave it behind in a safe place, such as under a rock or inside a rotting log. Most oothecas contain 50 or fewer eggs, but female cockroaches can produce many egg cases in their lifetimes. The adult stage of a cockroach may last a year.
And Murph wants to know, if all the humans went poof tomorrow, would cockroaches go back to their original range, or would they spread or are they spread too much? Well, the kinds that are considered pests are generally the ones that live in human settlements. They live in areas that are, I don't know, like you would not have, goodness, the American cockroach here, you would not have this one north of probably like, what, 35 degrees latitude, something like that. Anywhere it snows during the winter, you would not get these animals. It's just too cold for them. The reason that they exist in places like Canada is because of human beings and our nice, cozy, warm houses and warehouses, office buildings, etc. If you didn't have that, if everything was just ambient temperature, you wouldn't get that species all over the place, you know? Does that make sense? Yeah. That being said, there are native species that don't look like this. There's one specialized for different environments. Like, here we go. Here's the Canadian Encyclopedia.ca. Only 10 species are native to Canada. No, hang on. 3 species are native to Canada. Okay. Yeah. But yeah, for the most part, these are species, like, cockroaches in general like warmth. Which is that, there's that old thing that, like, oh, if there were a nuclear apocalypse and a nuclear winter, then cockroaches would be the only animals left alive. And this is complete bunk. Because they do really, really badly where it's cold, you know? In the aftermath of a nuclear winter, or a nuclear, like, in a nuclear winter, these guys would be some of the first to die. They don't, you know, they get chilly and then they croak. So yeah. The cockroaches are not immune to radiation. Yeah, there you go, Claire. They're fruit flies that struggle. Interesting, Claire.
We have much to learn about the age of reptiles.
Leo, no, thank you for the follow. Welcome to Paleontologizing. Good to have you here. Anyway, let's finish out this video.
Most oathecas contain 50 or fewer eggs, but female cockroaches can produce many egg cases in their lifetimes. The adult stage of a cockroach may last a year or less, or more. It just depends on the species. Eggs and nymphs will live for varying lengths of time, too, with some lasting longer than a year, meaning some cockroach species can end up living years on average. Once hatched from eggs, nymphs will shed their outer shell and grow until they reach adult size. In size, cockroaches may be as short as 3 millimeters or longer than 2.5 inches. Some can even have wingspans almost doubling their length. When they're young, cockroaches may appear white, but as they grow and their external skeleton hardens, they'll develop their adult colors. Cockroaches can also be kind of stinky, either from releasing pheromones to attract a mate, or to let other cockroaches around know they've found a yummy meal. But they're just born that way. For more facts on cockroaches, check out the links in the description. Give a thumbs up if you learned something new today, and thank you for watching Animal Fact Files.
There we go. Here's a link to that video there. But it does make me want to... Yeah, that's okay. Murph says, I mean, animals are still making it in the exclusion zone, so I'm sure... No, I'm not saying this is about radiation, Murph. Like, I do think cockroaches have some kind of basic resistance to radiation. What I'm saying is that they're just really vulnerable to cold. More so than most other insects, as I understand it. They really like warmth. And so, I don't know, if they get too cold, they will die. So yeah, in like a nuclear winter scenario, just because it's cold, if the sun is blacked out, I think the cockroaches are... I don't think they'd do so hot. No pun intended. Yeah. Anyhow. And tardigrade isn't a clade, is it? I think it is, Claire. Yeah, water bears, tardigrades, I think they are a clade. They're like proto-animals or super basal animals. Let's look them up. But I think they are a clade rather than a grade. Despite their name tardigrade, I think they are a clade. Let's see. Yeah. Water bears. They're not actually bears. Yeah, tardigrada. So they're a clade. What we're talking about here, for anybody who's wondering, clade, grade? What are you talking about? So a clade is kind of a basic unit of classification within biology. We're talking about how critters are related to one another through evolution. So here, we've got birds and crocs and lepidosaurs, which is mostly lizards, and turtle. It's funny, turtles should probably be moved. But anyway, each one of these, vertebrata, tetrapoda, amniota, reptilia, these are all different clades. So a clade is the ancestor and all of its descendants. So it's a basic evolutionary group. All these critters are related to one another because they all evolved from the same ancestor. So aves, the birds, they were a clade. They all evolved from one species. Crocs are a clade. They all evolved from one species. The crocs and the birds together form a clade called Archosauria. Dinosaurs are in here too, obviously. Part of that clade. So again, a clade is where all the critters are related. They all evolved from a common ancestor. That's different from, say, trees. Trees, like the plants, they are not a clade.
Gymnosperms have well-developed vascular tissues, enabling them to grow tall and thrive.
So this is kind of an introduction. This is not 100% correct, but it's a good introduction to the... I showed this with some plant people in the chat, and they're like, some of this stuff is not precisely true. There's some errors in here, but as a nice introduction to the idea of phylogeny with regard to plants, this is pretty good.
More close. Did you know an oak tree is way more closely related to a pumpkin than they are to pine trees?
Mm-hmm.
Look, here are the oaks next to the pumpkins, and here are the pine trees all the way over here.
So trees are not a clade. They're not all related to one another. The different plants that we call trees, it's all different kinds of plants. If it's a tall plant, people call it a tree, despite these things not actually being close relatives. You know what I mean?
Before I made this map, I thought that all of the trees evolved from each other, but it turns out the concept of a tree has evolved throughout history multiple times.
Well, prehistory, but yeah.
In this Map of Plants video, I'm going to look at all of the different kinds of plants on Earth and how they're all related to each other.
It's really cool stuff. So here's a link to that video if you'd like to take a look. But I love talking about this because this is like, it is the most basic fundamental principle underneath all of biology. And especially here in the United States, and in a lot of other countries, people just don't really, they don't know about this. Because it's not taught in schools. It's one of these weird things where, like, every biologist knows this, every paleontologist, every zoologist, every botanist, every ichthyologist. We all know this stuff. It's the most obvious thing in the world to us. It's a fundamental principle, but, like, for political and often religious reasons, this is not really taught in a lot of schools in the US and around the world. It's mostly a political thing, honestly. Like, when you have people like this running the country. Oh, school shootings happen because the schools teach kids about evolution. We're being led by insane people. This guy should be on a street corner, screaming and shouting, holding a cardboard sign, you know? He should not be second in line to the presidency of the most powerful and wealthiest country on earth. It's bonkers that this is the world we live in, but it's people like that who work very, very hard to make sure that these concepts are not taught in school. Because they're terrified of the concept of evolution and common ancestry. The idea that all living things on our planet are related to each other. I hate that idea, you know? Because on a certain level, it means that we're all equals. Human beings, at least. We're all worthy of dignity and respect and rights. And you know what? A lot of other critters probably are too. They're our relatives. That's just, I think, one of the concepts that people like this are terrified of. But yeah. Anyway. But yeah, Filippo. We've got dinosaur paleontologist Filippo Bertozzo in the chat here with us. There's a link to that article, by the way. So you know I'm not making this up. But yeah. Anyway, go follow Filippo if you want more dinosaur paleontology here on Twitch. Yeah. My flight to Italy in a few hours. Well, well, well. I hope it goes well, Filippo. Enjoy your time in, Italia. That would be the motherland, right? Italia Feminina? Italian is one of those languages, one of the Latin languages where nouns have different genders, right? And Easter break, very nice. Yeah. Anyway, very cool. Enjoy. I hope you have a good flight, Filippo. Yeah. See, Claire. Yeah. And if you thought my Spanish wasn't very good, my Italian is a million times worse. Anyway. Yeah. Wait, just a little clip to kind of highlight what I'm talking about here. I show this all the time, but it's worth it. When we're talking about this concept of homology, of common descent, of, you know, biological evolution.
Tree of life.
So this is from a documentary about a famous trial, the Kitzmiller versus Dover trial here in the US in 2005. So this was a famous court case where some religious creationists were trying to introduce religious creationism to a science classroom. They called it intelligent design as an alternative to science, you know. Anyway, there's a big court battle over it, and then there's an excellent documentary about that right here. There's a link in the chat for you. Highly recommend it. But anyway, this illustrates the point that I make.
At the time of the trial, so it couldn't be used as evidence. But Shubin's colleague, paleontologist Kevin Padian, showed the judge examples of other fossils with transitional features that support Darwin's tree of life.
My testimony in the trial was basically taking a...
No offense taken, Luke Urban's gaming, yeah. Appreciate your sympathy.
And showing the judge how we do our work and what the evidence is.
Is that tree of life again?
Evolved into birds, as seen in creatures like Archaeopteryx, which has a long tail and teeth like a dinosaur, but feathers just like a modern bird. How ancestors of modern reptiles evolved into creatures now extinct that share a common ancestor with mammals.
Yep.
And how surprisingly whales evolved from large land animals.
We'll be talking about whales today,
to the water.
If we land on those news stories.
And where the pandas book says we can't go from A to B, there are no fossils and we don't know how to study them. Actually, we've gone from A to B and to C, D, E, F, and G. We have the fossils, we have the transitional features, we have the ways of analyzing them with many different lines of evidence, and we're looking for the picture that accounts for the most lines of objective evidence.
And so the quote that I wanted to pull up is coming up in just a minute here.
With each fossil, Padian refuted Panda's claim that different life forms appear suddenly by showing how fossils of extinct organisms bridge the gaps between species, resulting in a picture of gradual evolution, just as Darwin proposed.
Here we go. Here's the kicker.
The reporters in the courtroom were just amazed that we knew all this stuff, and how come they hadn't learned about this stuff before? And the reason is, it's not in textbooks because the creationists fight so hard to keep it out. That's been a big influence.
Huge influence. There are millions, tens of millions, I'd argue hundreds of millions of people in the United States who might be really smart, clever people, well-read, well-educated, savvy folks, and they have no idea about any of this stuff because it's just not taught in schools, you know? I've met lawyers, I've met teachers, I've met inventors, historians, physicists, chemists. People who are like leaders in their professional fields, and they have zero concept of phylogeny like this. And this idea that living things are related to one another and that we've, you know, been able to make sense of the natural world. Their concept of different species, animals and plants and fungi, and it's still kind of caught in the Middle Ages, you know? They still have a medieval sort of understanding of like, oh, animals, they're sure weird, aren't they? What a big mystery. They're probably magic, I guess. Like, that's the majority of people that you encounter in the United States, even if they're really clever, well-educated, well-read people. And it's because this sort of thing just isn't taught properly in the U.S. So if any of you are watching, you're Americans and you, or from any other country, and you were lucky enough to learn about evolution and common descent in school, I want you to recognize how very lucky you are, because it's not a common thing, you know? It's one of the big reasons why I do these streams, and why there's always so much to talk about, is that folks have questions and misconceptions. I want to introduce you to what we've been able to discover as paleontologists and geneticists and marine biologists and botanists and mycologists and everybody else who studies the evolution of life on Earth. I want to share this with you because it's so cool to know about this stuff. There are so many mysteries that are still out there, things that we're still learning, but I think most folks don't realize how much we already know, how much we've already been able to figure out. So I'm here to share that with you. And a big part of that is, well, we're going to be going over some new discoveries today. Using our wheel of fossil news. So we will get to this momentarily. Well, let me catch up to chat. Yeah. And True Duck Lover says, evolution is not that hard to understand either. It's so weird. It depends. Like, certain people grasp it really quickly, but like, in my experience, people who work in more mathematical fields, like mathematics or physics or chemistry, they often have a really difficult time grasping the most basic concepts with it, you know? I've met a number of physicists, some of whom were like postdocs in physics, and they're like, yeah, bro, I don't know that evolution is real because I don't really get it. Don't get me started on physics envy and this lofty place that physics has in like the imaginations of a lot of people. Like, I don't know. Evolution and biology are much more complicated and difficult in a lot of ways. And so if you're a physicist and you're used to thinking of physics as being the queen of the sciences and the most complex and difficult, you physicists have to be the smartest. If you encounter concepts that maybe you find a little tricky, you're like, well, that can't be real because I'm the smartest one around. If I don't get this, it can't be legit. No, it is legit. It just has a lot more variables than you're used to. It's a bit more complex. There's more going on than just, you know, equation. I'm also oversimplifying here, but I hope you catch my drift. Anywho, yeah. And there you go, Harry Selden. I've seen this clip, yes. I know exactly what you're talking about, yeah. And Fried Egg says something really sad is that I substitute taught for a science class. That's not sad. That's good that you're doing that. I taught for a science class last week and was very happily surprised they still teach evolution in high school. Yeah. A lot of school districts in the U.S., they never touch it because they're afraid it'll be controversial. They're afraid that the parents will yell at them, or maybe the principal or the superintendent of the school is like afraid of the concept of evolution and discourages teachers from covering it. Like it's a major problem here in the U.S. and in a lot of other countries too. Oh, this is interesting. I haven't seen this before. This is by state. I was looking for the one by country. But here is kind of the rate of acceptance of evolution in different U.S. states. And this probably also reflects how much it's taught in each state. Vermont is the best. New England in general seems pretty good up here. New Jersey, New York, Maine, Alaska. California, we're pretty high on the list. Good for us. And then you get down into, oh boy, the deep south, Utah. Oh boy. Yeah. That's surprising actually to me that Utah is so low on the list. But yeah. Here's a link if you want to take a look. Alexander Morrison says, what's Florida's score? I instinctively want to scroll down to the bottom. No, actually, let's see. Florida right there. I'd say maybe 60th percentile? Good for you, Florida. Okay. I thought it'd be close to last. It's not. I should be a little kinder to Florida. Yeah. Dan the BC Man says Mormons are all creationists. That's not necessarily true. No, I do a lot of work in Utah. I work with a lot of paleontologists in Utah with the Utah Geological Survey. And not all LDS folks have any kind of problem at all with evolution. Some certainly do, and some don't. There's probably a bit of sample bias in that, like, I'm talking with the folks who are cool with evolution because I'm talking with folks who are interested in fossils. But, yeah. Anyway. Acceptance of evolution by state with treatment of evolution in science standard score is the title here. But yeah, at the very bottom, Arkansas. Oof. Well, here, like, bottom 10 are like Wyoming, Idaho, West Virginia, Oklahoma, North Dakota, Alabama, Kentucky, Mississippi, Utah, Tennessee, and Arkansas at the very bottom. Yeah. And Mirth says, I went to high school in Arkansas. We did a lot of biology, but I don't remember evolution being taught, at least not in detail. There you go. Yeah. What is the... Oh, here it is by country. This is what I was looking for originally. Oh, anyway, here it is by... Here it is by country. Out of... How many countries is here? 34? Blue is good. Blue means, like, people understand and accept that living things change over time. This means that, like, they get it. Iceland at the very top. Denmark, Sweden, France, Japan, UK, Norway, Belgium, Spain, Germany, Italy. Second to last, nearly at the very bottom, is the United States. Just not great. Really not great. We beat Turkey, at least. But that's it. So, yeah. Yeah. And it's interesting that South Korea doesn't seem to be on here. South Korea, as I understand it, also has, like, a huge creationist problem. I think largely because of U.S. influence, American missionaries and people like that. Den the BC Man says, where is Canada? I'll give you a link so that you can look at this yourself. Is Canada on here? I'm not seeing it. Interesting.
This is the sound of time.
Huh. But yeah. And Murph says, what are the three responses? True, false, don't know? Here, let me pull it up. This was a what? 2006 study, or I know I have this saved somewhere. Gosh darn it. And I need to have this bookmarked so I can pull it up in the future. NCSE. 34 countries. Why is this so difficult to find? To 2010. Search. Gosh darn it. This is different. Not what I'm looking for. My goodness. Why is this so difficult? This is really bugging me because it's such a crucial thing. I know I've got it saved somewhere here. I'm looking through my junk drawer folder. We might just have to return to this later. Yeah, darn it. Oh well, that's okay. I don't want to get too bogged down on this. And Urgle, let's see. This is it! Yes, thank you, Urgle. Bingo. That's it. Yeah, so the exact question that they were asked, the responses were true, not sure, or false. The question is, human beings, as we know them, developed from earlier species of animals. Is that true or false? It's basically like, does evolution occur? And does it apply to human beings? Is that... Did we arise from earlier species? Which, of course, is, what we know to be the case through the study of our own bodies and DNA and the fossil record and that of our relatives. It's basically, hey, do you think this is true or false, or do you not know this concept? That was the question that was asked in these different countries here. Here is that link, and I will bookmark this for future reference. Good. Yeah, excellent. Anyhow. Dinosaur Dave, how are you doing? Hello. Some kind of elasmosaurid. Okay. Skeletal fur, which means either new to science or closely related to Aramangosaurus. I'm not familiar with that taxon. Interesting. And it's got Chronosaurus bite marks on it. Very, very cool. That is awesome, Dinosaur Dave. Very exciting. Anytime we've got like a cool new Mesozoic fossil from Australia, that is cause for celebration. I hope they continue to find some good stuff there. Really neat. Really neat. Aeromangosaurus. Not a critter I'm familiar with. Let's look it up. Nice. You got a decent skull there. Not too shabby. Yeah, known from Queensland. I like the striking coloration on this restoration here. And thank you, Urgle Wurgle, for gifting Mother of Cats. I appreciate that, Urgle Wurgle. Thank you, thank you. Appreciate your generosity.
Tier 1 sub to Mother of Cats SC. They have given 300 gift subs in the channel.
Oh, what a cool picture there. I love that they superimposed the silhouette of the animal over this. Yeah, really neat. And again, in Australia, like, not a whole lot of topography. You don't have a lot of, like, cliffs and big valleys and stuff like that. Especially in places like Queensland. So it's like you kind of just dig straight down if you find some bones eroding out, and then there it is. Very cool. Dinosaur Dave says, Aeromangosaurus, sorry, named after the local language meaning windy plain lizard. Sheer coincidence. Aeromanga in Japanese means adult content magazine. Really? Oh boy. That's funny, Dinosaur Dave. Oh boy. No worries. Yeah. Very cool. So here this is in 2022. We may have actually gone over this in 2022 when it came out. We have vague recollections about this. Yeah. Neat. Very cool. But anyway, let's go ahead and fast forward 4 years into the future from this, or rather 4 years into the present in 2026. Time to go over some fossil news, introduce our wheel of fossil news. So without further ado, let's get into it. Let's play the fossil news video sting here. All right. Fossil news starts now. Introducing our new wheel of fossil news. We're going to be using this to select different stories from the world of paleontology. New papers just been published, new press releases, stuff like that, and kind of more broadly in natural history too. Paleontology is one of these fields that bleeds out into other disciplines as well. There's a lot of overlap between fossil science and zoology and botany and conservation. And I wanted fossil news today to kind of reflect that. So here I have collected a bunch of different stories, put them all here on the wheel. These are some of the things that we've missed over the past several weeks. We're going to do our best to catch up. So, without further ado, would somebody in the chat like to do the honors? Type the word spin into the chat. There you go, Lenina. Let's see what we get here. Ooh. Oh. Surprise Montana turtle. Ooh, I'm excited about this. Because this story happens to feature some friends and colleagues of mine from my alma mater. The headline is Turtle Fossil Narrows Timeline of Cretaceous Species Migration. Here's what you should know as background to this. Turtles first evolve around the same time as the dinosaurs. And they are related to dinosaurs a little bit more distantly than crocs. But they're certainly closer to dinosaurs than reptiles. Or, excuse me, certainly closer to dinosaurs than lizards, we think. They're all reptiles. But, here. Archelosaur phylogeny. That'll do it. Yeah. So when we're talking about the evolutionary relationships of these different groups, we have reptiles forming a clade here. You get lizards and tuatara. Over here, a little bit closer to dinosaurs, you get turtles. Then you get the crocs and their relatives. Then you get pterosaurs, and then you get dinosaurs, including birds. Does that make sense? And in some ways, the age of the dinosaurs was a good time to be a turtle. Especially later on. Peak diversity for turtles might be like the Hell Creek Formation. 67 or so to 66 million years ago, you had a huge diversity of turtles. Something like 25 different species of turtle from the Hell Creek Formation alone. This was... oh man, it was a good time to be a turtle. And the funny thing is, when that asteroid hits right after this, and knocks out all of the dinosaurs except for birds, and all the plesiosaurs and mosasaurs, and nearly all, or maybe all of the ammonites and other critters like that, turtles just kind of keep going. Only a small number of turtle species go extinct. For the most part, they make it right through. We've got another news story about that today. We'll see if we land on that. But one of the big turtles that does not make it through is Basilemes. King turtle is what the name means. This is not a tortoise. It's outside of that family, but you can think of it as being similar to a tortoise in its lifestyle. This is a big turtle that's walking around on land, and they do get big. Basilemes. Here it is compared to a cowboy. No, I'm just kidding. That's not the scale. The little silhouette next to the guy in the cowboy hat is how big it is. Yeah. And they're dead? Yeah, Basilemes is no more. So this is how big it is compared to a human guy. The turtle guy, human guy, these are to scale. It's not actually this big compared to... This is just a detailed view. Do I make myself clear? Anyway, but this critter was walking around at the same time as T-Rex and Triceratops and Pachycephalosaurus. It's a cool critter. Basilemes. Oh, that's a neat illustration there. A little dromaeosaur on the back of a Basilemes. Yeah. Basilemes. King turtle. We've got a new fossil of this critter. And I love this press release here. I'll give you a link. Before leaving on a fossil hunting trip for a summer 2021 field paleontology class, a Montana State University junior, that's the school I went to, made an apparently fate-tempting plea. I kept joking through that whole class, "Oh, please, just anything but a turtle," said Jack Prawl, now a doctoral student in Montana State's Department of Earth Sciences and the College of Letters and Science. Letters and Sciences, but yeah. Prawl had prior field experience in his home state of Colorado, where fossil turtles are abundant. So he hoped to find something more novel to him in the frontier geological formation near Lima in southwest Montana. It is pronounced Lima. I've done field work in the frontier formation, looking for dinosaur footprints and stuff. It's right on the Montana-Idaho border. And pretty much right on the Continental Divide. Here's the town of Lima, Montana. It's barely even a town. There we go. So here it is. It's basically right on the Montana-Idaho border. Right there. And so this squiggly line here is the Continental Divide. Or it largely corresponds to the Continental Divide, which is kind of the peak of the Rocky Mountains. What's cool about the Continental Divide is the idea, it's that red line there. The idea is that any rain that falls on the west side of it goes to the Pacific Ocean. Any rain that falls on the east side of it goes to the Atlantic Ocean. So it's kind of the peak of the roof of North America. If something falls on one side, it goes this way. If something falls on the other side, it goes the other way. Does that make sense? True Duck Lover says, that's actually so cool. It really is. It's even cooler. Well, this is kind of a tradition for paleontologists and geologists doing fieldwork along the Continental Divide. Is you find where the exact line is supposed to be. It's kind of a rite of passage. And you urinate on it. You pee on it. You try and pee on either side. And you're like, half of this is going to the Atlantic, and half is going to the Pacific. So I've done that several times. Continental Divide. Yeah. But, this turtle is from basically right there, which is really cool. So anyway, this guy, Jack Prawl, did not want to find a turtle here. He's like, I found turtles before. They're common. I don't want to find this. And what is that? Crimson Card of the... I don't understand that reference. You wanted to find anything other than a turtle, and he says, of course, one of the cooler finds on that class trip was this turtle. At the time, Prawl didn't know that this turtle would turn out to be the oldest confirmed specimen by about 5 million years of the genus Basilemys, a meter-long terrestrial turtle that lived in North America during the mid to late Cretaceous. The journal Historical Biology recently published a paper by Prawl and fellow MSU graduate student Brendan Clark, describing how they and their co-authors determined the specimen's age and discussing the scientific significance of the 89-million-year-old animal. Most of the oldest confirmed fossils of this turtle get up to 84 million years old, said Clark, whom Prawl describes as the resident turtle specialist among MSU's current group of earth science graduate students. Which is funny, because when I was at Montana State, there were a couple of other turtle people. Dan Lawver and Mike Cannell were both turtle guys. They must be elsewhere nowadays. So, there's a new King of the Turtles at Montana State. Brendan Clark. Anyway, this is definitely the oldest directly dated fossil of Basilemys known so far. So this is the oldest member of this genus. And that's really important for paleobiogeographical reasons. I'll show you. Prawl began studying the specimen for an undergraduate research project, but before finishing it, was ready to shift his focus to his unrelated PhD research. In 2024, he invited Clark, who's preparing his master's thesis on another Montana fossil turtle from the mid-Cretaceous, to fill in the gaps and get this project over the line. This is often what we do in the sciences, is like, we're working on something, and we kind of hit a wall, you know? I don't know enough about this particular subject. I don't necessarily have the time to become an expert in this. So let's bring an expert in for help. Like, let's get a turtle person in here and have them help out with this so we can get the thing published. Clark agreed, hoping the Basilemes would offer insight into the formation of ecosystems in the Cretaceous. At the time, neither student realized what the fossil would reveal about the large interchange of animals between Russia and Alaska during that period. Another bit of background information here. Paleobiogeography. This is roughly what our planet looked like around 85, 90 million years ago. Sea levels were really high. There's this big shallow seaway in the middle of North America. But you'll notice Montana right here used to be able to walk from Montana all the way here across this land bridge and into Asia. Used to be able to walk from, say, China or Mongolia or Russia across this land bridge into Alaska and then down into what is now the western United States. So you could go from Russia to Montana. And that's exactly what these turtles seem to have done. The juvenile specimen, whom the students nicknamed Donatello, in honor of the nerdy Teenage Mutant Ninja Turtle of cartoon fame, did not disappoint. To determine how long ago Donatello died, Prahl and Clark sought help from fellow graduate students. One of them, Zach Hennebaum, analyzed sediment collected within the fossil. I said it with the fossil in a geochronology class taught by MSU Associate Professor of Geology, Devin Orme. Once we started getting more and more interesting dates, we brought in Dr. Orme and were able to get a much closer idea of how old the rock is, Prahl said. It fell out around 89 million, which was really, really exciting when we got those numbers back. The genus Basilemes belongs to the extinct Asian Nasciunchilidae family of large land-dwelling turtles. But Basilemes specimens have only been found in North and Central America, suggesting that the genus evolved after its ancestors migrated toward North America. Importantly, Basilemes is the only turtle in its family that's in North America. The rest are from Asia, Prahl said. Keep in mind, this is a land-living turtle. Think of it almost like a tortoise. This is not the sort of animal that's going to swim across an ocean. It's a land turtle. We have family members going back around 112 million years, but we don't have a really good idea of how that dispersal happened, or especially when that dispersal happened. This fossil really helps to narrow down that time in which that migration could have occurred and helps strengthen the hypothesis out there about the migrations that are happening during this greenhouse event. So when we're trying to figure out when exactly these land bridges formed, when they were inundated by high sea levels and when sea levels drop, the land bridges form, what's the timing on that? When are these events happening? One of the ways of figuring that out is to look at animals and plants and when they show up on these different continents. Because if sea levels drop, land bridges form, and you can walk across, you'll get different groups of organisms doing that. So when they show up on a certain continent, you can say, oh shoot, this must have been right after a low sea level time, there must have been land bridges. It helps you kind of make sense of these things. Does that make sense? Good dinosaur Dave, yeah. True Duck Lover says, I can't believe this animal crawled here. Like, imagine crawling that entire way. Not swimming or walking, but crawling. Well, that's the thing, True Duck Lover. It's not a single one of these turtles that would have done that. You're not talking about one turtle walking all the way from Alaska to from China to Montana. This is like hundreds or thousands of generations of these turtles. They're slowly expanding their range across that land bridge, and eventually, some of them get there, you know? Oh, you're being dramatic. Okay, no worries. Yeah. But it is really cool. Like, even a relatively slow-moving animal like this, you give them enough time, enough generations, they spread across entire continents, or from one continent to another. Yeah. Scientists believe the ancestors of basilemys began migrating during a period of increasing polar warming between 100 million and 113 million years ago. So temperature is really important here too, because, you know, this is up near the North Pole. And famously, turtles, they don't live at the North Pole today. It's a little cold. You know, this is not really very good turtle habitat up here, if you can believe that. They kind of need it to be a bit warmer, you know? So in order to spread across that land bridge, it had to have been really warm up here at the time. And so you'd have to wait for a really warm spell, and this is exactly what we get. We've got pretty good ideas of what Earth's temperature is doing on a global scale at different points in Earth history. And so, yeah, here we go. During the Cretaceous, for instance, Cretaceous period, we've got this big peak right in the middle. And that's probably when these turtles are moving across during the Cretaceous. When global temperatures are at their highest during the Mesozoic like that, that's when they're moving across. So you see what I mean about these different scientific fields kind of converging? Just in a simple story like this, it turns out not to be so simple. We've got turtle taxonomy and phylogeny. What kind of turtle is this? Who is it related to? We got to figure that out. We've got geography. We've got global temperature, so climate science. We've got geochronology, trying to figure out when exactly this turtle is from in time. All of these different things converge, you know? There's so many different things that you have to understand to make sense of these fossils. You know? Very integrative. Integrating all these different fields of science together for a more complete picture of what's going on, you know? Yeah. Claire Burr says it's like the Avengers. No, I think they said Ninja Turtles, right? Yeah. Teenage Mutant Ninja Turtles. But yeah. Anywho. Still, because they sometimes would have been exposed to freezing temperatures, it's unknown how the turtles survived in polar regions. The paper suggests they may have engaged in burrowing behavior or entered states of winter dormancy to survive, and some turtles do this today. We've got turtles in North America and in Asia today that live at higher latitudes, and they're surviving at the bottom of ponds that are freezing over. Maybe these turtles were doing that, or well, they're tortoises, so they're not under the ice in a pond, but maybe they're digging burrows and hanging out underground where it's a more constant temperature. They can stay a little warmer. Stuff like that. Yeah. Okay, fossil turtles are representative groups commonly seen later in the age of dinosaurs, which ended 66 million years ago. Clark and Prowl said seeing them so much earlier in the fossil record sheds light on the origin of ancient ecosystems and provides insight into how turtles responded to shifting climate in the past, thereby further understanding the evolution of ecosystems in North America during the Cretaceous. The authors are certain that Donatello, this particular specimen, lived a lifestyle similar to that of a modern tortoise, in balmy conditions at the western edge of a vast inland sea. Because of only a small part of its shell was recovered, Prowl said that there was no way to determine whether Donatello represents a new, previously undiscovered species of basilemys. They don't have enough of this animal to figure out if it's a new species or not. Unfortunately, the fossil record gives us what it gives us. But we'll go out and look for more, said Prowl, no longer wishing for anything but a turtle. Donatello is one of many scientifically significant fossils found in southwest Montana since the turn of the century, including an older turtle fossil that Clark is studying for his master's thesis. Near the frontier formation lies the older Blackleaf Formation. This is where L.J. Krumenacker works with Eryctodromius, this burrowing dinosaur. Now the state dinosaur of Idaho, excuse me. State dinosaur of Idaho, Oryctodromeus. We know it lived in burrows. That's from the Blackleaf Formation. Yeah, there we go. 2004 MSU graduate, that's L.J. Krumenacker, discovered the 95 million-year-old bones of an adult and 2 juvenile Oryctodromeus in a burrow. If you want to learn more about this critter, I did an interview with L.J. Krumenacker in Idaho. There we go. Talking all about this.
Look at it. So that's my hypothesis. That's really cool. That's really cool. Here,
I guess our internet was a little spotty.
But really, we should change because we do have dinosaurs here.
There's a lot of potential.
Yeah, seriously.
Oh, here we go. Oh, shoot. Wrong button. Gosh darn it.
Permian-Triassic extinction, as we mentioned, and I'm working on a Eocene, about 50 million-year-old bird.
Anyway, here's a link to that if you'd like to take a look at that VOD, talking about Idaho dinosaurs. And yeah, Petrodactylus, LJ's got several living dinosaurs in his house.
He was saying that they heard some birds. Should we take a look at those zebra?
The zebra finches.
Yeah, let's
totally fine.
Do they have names?
Let's see. Batman and Rico, Sean, is that the name of our zebra finches?
That famous dynamic duo. Batman and Rico.
Yeah. Batman and Rico.
Right.
I don't remember which is which.
Well, hello.
You know them. Batman and Rico.
It's funny, I walked in here for the first time. I'm like, is that a squeaky toy going off? Is there a dog playing with a squeaky toy? But no. Little zebra finches. They are beautiful.
I like them. They're fun to listen to and have around.
Yeah. Little theropods. Very cool. Very cool. So yeah. Shoot, I'm sure we're going to be doing a lot of talking about Oryctodromeus, first of all.
Anyhow. Batman and Rico. Anyhow. So the fossil sites are managed by the U.S. Department of Agriculture Forest Service, which Montana State University professor of paleontology Dave Verricchio credits for further scientific discovery by granting access to professional and student paleontologists. We did an interview with Dave last year. He was my undergrad advisor at Montana State. Allowing researchers and students to work on these specimens gets them preserved in public museums, protecting the fossils for the common good, Verricchio said. Pretty cool stuff. Well, anyway. And there's Jack Prawl on the left and Brendan Clark on the right. Looking at some turtle bits, I guess, in this photo. Nice stuff. Good old basilemes. Excellent. I'm hoping we find some of this critter in Wyoming. Maybe this coming June, when my crew is working out there. Yeah. Anyhow, good stuff. So there you have it again. Here is a link if you want to read more about this. And I'll go ahead and take that off of our list, and we will jump into our next fossil news story here. There we go. You ready, chat? Would somebody like to type spin into the chat there? And we'll go ahead and spin this. Thank you, Alexander Morrison. What have we got? Ooh. Oviraptor eggs needed sun. Let's get into that. Here is a link to the press release right here. Just missed the Triassic Croc one. We'll see if we get to it. This was really cool. There are a couple of different press releases here, and I chose what I thought was the more interesting one. Dinosaurs hatched from eggs less efficiently than modern birds, researchers show. I don't love the headline. I don't feel like that really tells us. What do you mean hatching efficiently? What? What? But the rest of this is good. What is going on here? It looks like some sort of roadside bomb or something, but it's not. What do we really know about how the Oviraptorosaurs, bird-like but flightless dinosaurs, how do we know how they hatched their eggs? First off, let me show you what these critters look like. The Oviraptorosaurs, sometimes called the egg stealer dinosaurs. It turns out they weren't actually stealing their other dinosaurs' eggs. It's kind of a funny story. In fact, I'll show you a clip from a stream. Here we go. When I was at the Badlands Dinosaur Museum with my old boss and crew chief, Denver Fowler.
A number of times, like different sizes, like all these boxes look about the same size, but if they're close to the front or if they're at the back.
So Denver Fowler runs the Badlands Dinosaur Museum in Dickinson, North Dakota.
They're the same to you, but they're actually all different sizes.
And when well, ages ago, when Denver had just gotten his PhD, he applied for this job in North Dakota. They were reopening this museum after it had been dormant for years and years. They were looking for a paleontologist to build it into a world-class museum. And Denver was the right guy for the job. I actually drove him out there for both of his job interviews, all the way from western Montana to North Dakota. And he got the job, and he's been doing incredible things there ever since. Summer of 2017, I spent some time at the museum helping design exhibits and just helping with all kinds of various things.
It's really boring, that kind of thing. It's almost as boring as different light bulbs, but
it's important though.
Once
like,
you start
yeah.
putting these things together, like you start getting appreciation for the different scaling and sizes of panels.
Definitely, yeah. Neat. And I recognize that piece of artwork there too. I've shown this on stream before. That Oviraptorosaur? Was that City Patty, I think?
So, what does it say here? Oh wait, does it not say? Oh, I guess there's my signature right there. Anyway, that's some original artwork that I did for this museum, for this display in particular. There's an Oviraptorosaur sitting on a nest of eggs.
Yeah, or Oviraptor, either one. But yeah.
I tell people that this is my favorite display in the museum.
This one?
Yeah, and these days maybe it's one of the newer ones, but this was at the time my favorite, because it shows the process of science. Here it is.
Mm-hmm. Yeah.
That back in the 1920s, the American Museum went to New York.
Mm-hmm.
They found dinosaur eggs, and
they went to Mongolia. He meant American Museum is from New York. They went to Mongolia and found dinosaur eggs.
Found baby dinosaurs, these Protoceratops babies, and they said, "Oh my God! Like, Brent, we've got nests of Protoceratops," and so
And Protoceratops is a dinosaur who looks like this. There we go. Protoceratops. Yeah. In fact, I've got them in a book over here. Roy Chapman Andrews was expedition leader from the American Museum of New York City and went to Mongolia. Found a bunch of dinosaurs, including... There we go. including, on this hillside, fossils of dinosaur eggs. This was huge at the time. Big, big, big deal. And this dinosaur, Protoceratops, was all over the place. Just everywhere. They said they're like the sheep of the Cretaceous period. They're just everywhere. So there it is with a nest of eggs. And there you go, yogurt girl. Yeah, that's exactly what I was going for, that kind of image.
When this museum opened in 1992, in 1993, this is one of the models that they had, and it's a bunch of baby Protoceratops and a bunch of those eggs that were found by the American Museum. And the same year that this model was made, the American Museum had been back to Mongolia, and they'd found more of these eggs, of course, and they cracked a few open, and inside they found oviraptor embryos.
Yeah, not Protoceratops.
Not Protoceratops. Yep. And of course, back in the 1920s, they'd found an oviraptor standing on top of these eggs, and they thought the oviraptor was stealing the eggs of the Protoceratops, so they called it egg thief oviraptor.
That's what the name oviraptor means. And so, in all kinds of different paleo media, you'll see these depictions of oviraptors stealing eggs. That's just what they do, right? It's an egg thief. You had this in Disney's Dinosaur as well. You know, oviraptor, the egg thief. What a dastardly little guy, just stealing everybody's eggs. Here you've got a Protoceratops who had just laid a beautiful nest of eggs, and then there's an oviraptor lurking in the background, just waiting to steal those eggs there. See that? Here you go. Give me those eggs. Let me steal them. You know? Looks like a lizard here. That's ridiculous. But anyway, it turns out the American Museum went back to Mongolia. They found more of these eggs and nests like this. First, actually, here, let me... Where's that image? With the, Yeah, oviraptor was just notorious for this, you know? Always stealing those eggs. Here, I'm trying to find that image because I found it really amusing. I can find it faster on here than I can find it in the book. Where did that go? Here is a depiction of a mother Protoceratops catching an oviraptor in the act of stealing her eggs. She's not happy, and he is... Well...
Headshot.
Yeah. Oof. Oof. And illustrators felt comfortable doing this because it's like, well, it's an egg-stealing dinosaur, you know? Who's gonna feel bad for it? But as it turns out, these Protoceratops eggs were not Protoceratops eggs. As Denver says here.
20s, they'd found an oviraptor standing on top of these eggs, and they thought the oviraptor was stealing the eggs of the Protoceratops, so they called it egg thief oviraptor. And now we realize that the oviraptor was actually protecting its nest, and that these are oviraptor eggs. So I tell kids, it's like, if this model shows anything at all, it shows a bunch of baby protoceratops smashing up an oviraptor nest out of pure spite. That's why they look so happy. So this will learn you. But it shows the process of science.
Yeah.
And it shows that, it was a good hypothesis. You had baby dinosaurs, you had eggs.
Mm-hmm.
Why aren't they both related? But it turned out that they weren't.
Mm-hmm.
Cool. So yeah, really cool stuff. Anyway, here's my illustration here of an oviraptor brooding his or her nest right there. And that is what this new discovery is all about. Yeah. Trick Track says, do they have to be renamed then? Nope, that's not really how it works. Even though the name oviraptor means egg thief, and now we don't have any evidence that they actually stole eggs, that's not one of the acceptable reasons why you would rename a dinosaur or any other kind of animal. The name has to stay what it is. It's not like one of the accepted list of reasons why you would rename something. And City Patty is a new name. Yeah, Clipper. So what's kind of funny is when the American Museum went back to Mongolia and they found specimens like this. This is the Big Mama oviraptor specimen. There we go. What you're looking at is a view from underneath, up at the belly of an oviraptor. So there's the rib cage there. Here's the legs folded underneath it. Again, it's like this, but you're looking at it from underneath. So here's the legs folded up underneath. You see the toes there. There's the upper part of the foot. There's the ankle. Here's the arms stretching up around, and there's the eggs. Okay. When this was first discovered, they're like, oh yeah, it's another oviraptor. And then they realized it looks a little bit different from the original oviraptor skeleton. It's got to be a different species from the same family. So they named it City Patty, which means funeral pyre lord. Yeah. City Patty. I think it's Mongolian. I think the language is Mongolian, but I could be wrong.
Dinosaurs were the sort of creatures you might think of as inhabiting another planet.
Protoceratops.
Or the kind you dream of in a bad nightmare.
Yeah.
Ye 30 months in Sayanti.
What about City Selma? Oh boy, Crimson. Anyhow. Thank you, Casmiel Black, for the 30 months of support. Really appreciate that. Thank you for keeping me here on the air. That means a lot, and I really appreciate it. Thank you. So anywho, that's what this new paper is about here. So what do we really know about how oviraptorosaurs, bird-like but flightless dinosaurs, hatch their eggs? Did they use environmental heat, like crocodiles? Or body heat from an adult, like birds? In a new Frontiers in Ecology and Evolution study, researchers in Taiwan examined the brooding behavior and hatching pattern of oviraptorosaurs. They also modeled heat transfer simulations of oviraptorosaur clutches and compared hatching efficiency to modern birds. To do so, they experimented with a life-size oviraptor incubator and eggs. What? Let's take a look. We show the difference in oviraptor hatching patterns was induced by the relative positioning of the incubating adult to the eggs, said senior author Dr. Su Rui Yang, an associate curator of vertebrate paleontology at Taiwan's National Museum of Natural Science. Moreover, we obtained an estimate of the incubation efficiency of oviraptors, which is much lower than that of modern birds, added first author Chun Yu Su. The reconstructed oviraptor, Heyuania huangai, there we go. It looks a lot like Oviraptor. There's a bunch of species within this family. Yeah, we're looking at a critter like that. Beautiful skeleton right here. Look at that. Gorgeous. Look at that. I mean, so many of the dinosaurs that we get from Mongolia are nearly complete, extraordinarily well preserved. This is just gorgeous. I know, right, Shark Geek? Amazing, right? Yeah. Yeah, and the pygostyle, the shortened tail vertebrae. So you'd have like a big feathered fan at the end of the tail, like we see here. And here, and here. Oh, and here. Nice. Yeah. Anyhow. This critter lived in what's now China, I think Inner Mongolia, between 70 and 66 million years ago. About 1.5 meters long, around 20 kilos, 40 pounds or so. Built semi-open nests made of several rings of eggs. The incubating oviraptor's trunk was, and it's funny that they're using the term oviraptor here as like a catch-all for the whole family. More properly, I think you would say oviraptorosaur. But they're not doing that for whatever reason. So anyway, they built a model with an oviraptor's trunk made from polystyrene foam and wood for the skeletal frame, and cotton, bubble paper, and cloth for the soft tissue. Eggs were molded from casting resin. In the two clutches used in the experiments, eggs were arranged in double rings based on real oviraptorosaur clutches. So they've got a model of the eggs with like thermistors in them, a thermometer basically inside these artificial eggs. And they put an artificial adult on top with similar insulating properties to what the real animal would have had. Again, just trying to build an experimental model here. This is really cool. Shark Geek says, what is it about Mongolia that preserves them so well? It's a good question. In a lot of these cases, it was a fairly dry, arid environment. And so these animals, they might have been covered up by like landslides of sand, sandstorms. For a lot of these animals, they probably died in burrow collapses. So like, we get a lot of protoceratops that are preserved in situ. So I can find you an illustration. Yeah. There we go. So they're preserved in 3D. Like, what in the world? It's not like you had a carcass that was lying on the surface for a long time and everything decayed and scavengers are throwing the bones around and everything's getting chewed on. It's like it's like they died standing up. Or not quite standing up, but like slightly smushed from above. Like, what? What? What's going on here? And you get so many different animals that are like this in Mongolia. Here's a really famous specimen. A protoceratops and a velociraptor preserved together. They died locked in mortal combat. How in the world do you get this kind of preservation? There's an idea that that maybe it was a situation like this. Uh-oh. What's gonna happen? Not quicksand trick tracks. Good guess. I don't think any other velociraptor are found nearby, Crimson. I've never quite found this explanation all that plausible. Here. It is Christian Slater, Game Over. Good ears, yeah. He narrated this. And hang on a second.
The world's first armored tank, you might say.
Yar the Goose.
That trunk is completely covered with thin, bony plates.
Thank you for the follow. Welcome to Paleontologizing. It's good to have you here. So this is an interesting hypothesis, you know? Excuse me. It's an interesting idea. Here's a link, by the way. I've never quite found that to be all that plausible. I think there's a better explanation for how those critters were preserved together. We now have evidence that, well, I've actually worked on a site in Montana. Let's see, here we go. I'll let Denver tell this because this was his site. He first found it. In 2012, we were prospecting out at Hell Creek State Park in Montana. And Denver found these little leg bones that were this... at first we thought it was from a Thescelosaurus. Little beaky plant-eating dinosaur. Like this. Little leg bones. Really beautiful, like, weathered light color. Almost like a buff, sandy, almost blonde color. So leg bones, blonde color. we'd been listening to a lot of Flight of the Conchords band that summer. And so Denver named the site after one of their songs, Leggy Blonde. So the site is called Leggy Blonde, and Denver now regrets calling it that because it's turned out to be an incredibly important site. It's not Thessallosaurus, it's something way more rare and special. Leptoceratops, which was kind of a mysterious dinosaur from the Hell Creek Formation. Find you a good there's a pretty good one. Yeah, Leptoceratops. Here it is here. This is going to go on display at the museum. They're still working on this exhibit, as I understand it. And I'd love to be able to go back out there to North Dakota once it's done and show it off to everybody.
Intricate as the delicate things, but they have their own challenges. With
Yeah.
their size and, the cradling and things.
Very cool.
Yeah.
And then the ceratopsian in the room. Do you want to talk about this, Denver? Because this goes back to
Sure, I mean,
2012.
This is something that Danny dug up with us back when I was at the Museum of the Rockies, a graduate student there. It's a site that I found in
let me get on this side over here.
2010.
And no, it's 2012 you found it.
I found it in 2012.
Thessallosaur, yeah.
Yeah, we thought it was a Thessallosaur, but I presented about this here at our own conference, and you may have read a little bit in places, but we found a Leptoceratops bone bed. And
so a bone bed is where you've got a bunch of individuals, at least more than one, usually more than two, bunch of individuals in the same site. So like you get a bunch of the same bones again and again. So like multiple right femurs. So, each individual only has one right femur. So you've got multiple individuals. Leptoceratops is an extremely rare dinosaur in the Hell Creek Formation. At least we thought that it was. Turns out there's actually a trick to finding them. They're not rare. They only occur in very specific environments. You find those environments, you will find leptos. But, yeah.
We have remains of 2 adults and all sorts of things. 1/3 size individuals, we have hatchling grade individuals. So these are part of an exhibit that we're putting together showing a Leptoceratops burrow. These are animals that lived in burrows.
Yep.
Based on some of the new information that we're basically putting together.
And I'm so glad that we could talk about this because I've been super cagey about this on stream.
Well, I'd still be super cagey. I'm just doing like a little exclusive. I'm not going to go into any details. But, what's in the abstract that we presented is already out there.
I didn't realize that, So.
It's an exclusive for this, for when we did our own little meeting here. But we've had, basically, you can't get a skeleton of a Leptoceratops anywhere. I tried to find casts, Canadian Museum.
Anyway, so Leptoceratops, this dinosaur from the Hell Creek Formation, we now have really good evidence that this animal was a burrower. These critters raised their young in burrows. This is a close relative of Protoceratops, this dinosaur that is often found preserved in 3D like that. Found just like this, essentially. Like, how in the world did they get preserved? Well, not quite like that, but, those are mounted skeletons, but like this. Like, how in the world? What? What? How did that happen? Well, these are probably burrow collapses. That's why the rib cage is kind of flattened like that, but the animal is otherwise still in articulation. Not preserved on its side. It's like this animal was in a burrow, the thing collapsed, and it's just, it's a little bit squished, but it's still all together. That's what I think happened with the fighting dinosaurs, too. I think that maybe Velociraptor, in a desperate attempt to get some food, crawled into a Protoceratops burrow, they got into a fight, and the roof collapsed, and they're preserved together like that. That makes a lot more sense to me than, like, yeah, they're fighting, and then a hillside collapses around them. A dune falls over and buries both of them. That doesn't make a whole lot of sense to me. But a burrow collapse, we have evidence that these animals lived in burrows, and it makes sense to me that this is how you would get this kind of preservation like that. But yeah, a home invasion, exactly, Claire. Yeah. But yeah. Either way, buried alive is so scary, says Yogurt Carol. For a lot of these dinosaurs from the Gobi Desert of Mongolia, that seems to be how they died, is they were buried alive. Whether it's these guys, whether it's these Oviraptorosaurs like this, buried alive. Yeah. Sometimes it seems to be sandstorms. Maybe it is some dune collapses. For some of these guys, it's burrows collapsing. But yeah. And have many other tiny ceratopsians been found in what could have been burrows, says Crimson Carnotaurus? Yes. A lot of the Psittacosaurus stuff, that might be burrows. Montanoceratops, that could be burrows too. Yeah. So anywho, I gotta pay rent here. Mini Pie is back. You've returned. Huh. Yeah. We gotta get through this fossil news story. So, I thought makes me panic, says Yogurt Girl. Don't go digging any burrows, then. I guess that's my piece of advice. Other than that, you're probably safe. But don't try to raise your young in a burrow. Huh. It works for a lot of critters. But, yeah. And, oh yeah, Cacklinsworth, that was, a Dicynodont and a... Cynodont? Was it a Cynodont and a Dicynodont found together? From the Karoo Basin of South Africa in the Permian period? Yeah. But yeah. That's a common thing. Like, I think burrowing animals might be overrepresented in the fossil record. Because, well...
Here's a step-by-step guide.
Because you can kind of mix up some of your steps here. If anybody in the chat has ever aspired to become a fossil, and you've looked for a step-by-step guide on how to make that happen, well, shoot, you're in luck.
Here's a step-by-step guide to becoming a fossil. Step 1, die.
It does take a certain degree of commitment, you know? Takes real dedication to become a fossil. I'll put it that way. But what's step 2 after die?
Once you are dead, your remains may be scavenged by other organisms.
It happens.
Step 2, get buried fast.
So here's the thing. Sometimes you can get buried before you die. And that way, your remains won't be scavenged by other organisms, at least not as much as if you're just there on the surface dead. If you can get buried first, before you die, you stand a much better chance of becoming a complete fossil, you know?
Step 2, get buried fast. If you are buried rapidly, your remains won't completely decay or be carried away by scavengers. Your best bet for rapid burial is to die near or in a river
there you go, Yara, yeah.
or ocean, where water can deposit sediment over you. Step 3, soak in groundwater for a long, long time. Groundwater contains minerals. Over time, dissolved minerals can harden after filling in cavities in your skeleton.
There you go, Crimson,
the water can dissolve your skeleton, leaving only minerals in its place. Either way, your skeleton will turn to stone, and you'll be a fossil.
There you go. Immortality.
Step 4, wait to be exposed. As the years go by, if you're lucky, sea levels can fall or rock can erode and expose you. Then, if your luck holds out, you might get spotted by a fossil hunter. and wind up in a museum collection where scientists can study you to learn about evolution.
There you go. That's the dream, isn't it? Yeah. Anywho, I gotta pay rent here. Oh, Mini Pie. Yeah, don't tell Sweetie, okay? She's not supposed to get treats anymore. What's this about? Ooh. Look at that. You can eat those, or you're just gonna lick them? There you go. Crunch them up. Use those teeth. Dental treats after all. Why are you eating so furtively? Nobody's gonna get you. Just eat. Being so cautious. And there you go, Mayor Space. That is one of the hardest parts, for certain. Yeah. Anywho. Are we only on fossil news item number 2? Shoot. This is going a lot slower than I was hoping. But, let's continue with this. And, we can always continue tomorrow if we want. Excuse me. Goodness. So, Oviraptorosaurs and their eggs. How do these dinosaurs incubate their eggs? This was an interesting approach to that question. Yeah, part of the difficulty lies in reconstructing Oviraptor incubation realistically, said Sue. For example, their eggs are unlike those of any living species, so we invented the resin eggs to approximate real Oviraptor eggs as best we could. When the team ran experiments to find out if clutch attendance of a brooding adult or different environmental circumstances may have impacted hatching patterns, they found that in colder temperatures, where a brooding adult attended the clutch, the egg's temperatures in the outer ring differed by up to 6 degrees Celsius, which could have resulted in asynchronous hatching, a pattern where eggs in the same nest hatch at different times. Anybody who knows a thing or two about how birds incubate their eggs knows that generally you want your hatchlings to hatch around the same time, you know? You don't want one baby to hatch and then you have to wait weeks for the next one to hatch. That's not a recipe for success. You want them to hatch more or less synchronously, because it's easiest to take care of them that way. In warmer conditions, the difference in egg temperatures in the outer ring was just 0.6 degrees Celsius, suggesting that oviraptors living in warmer conditions may have exhibited a different pattern of asynchronous hatching because they could use the sun as an additional powerful heat source. It's unlikely that large dinosaurs sat atop their clutches. Yeah, because if you're a big, heavy animal and you sit on your eggs, you're gonna crush them. Supposedly, they use the heat of the sun or soil to hatch their eggs like turtles. Since oviraptor clutches are open to the air, heat from the sun likely mattered much more than heat from the soil, Yang explained. So here's those model eggs there, buried in a dirt mound, just like an oviraptor would do. And there you've got those wires going out to the thermometers. The team also investigated how oviraptor incubation efficiency compared to that of modern birds. Most birds use thermoregulatory contact incubation, TCI, where adults sit directly on the eggs to transfer heat. But TCI requires 3 prerequisites. You need 3 different things in order to get that method to work. The adult bird must be in contact with every egg. The adult must be the main heat source, and must maintain all eggs within a constrained temperature range, which oviraptors didn't fulfill. For example, their egg arrangement prevented the adult from making full contact with all the eggs in a clutch. And we know this because of specimens like this. So we can see how the eggs were arranged.
Surely one of the most remarkable animals that have ever existed, and certainly one of the most famous,
is Dirt or Bust.
Paleo Biofeed,
okay.
the stream, Paleo Science.
Thank you,
Paleo
Dirt or Bust, for the 2 months of support. 6 months of support. Really appreciate that. Thank you, Dirt or Bust. I appreciate you keeping me here on the air. Thank you. Pretty cool. And Case Kuchin says, is there a theory why breed like most birds? Oh, different creatures using different methods to incubate their eggs? Well, all of the birds that are around today pretty much sit on their eggs to keep them warm and incubate them. Birds are warm-blooded, so birds generate their own body heat from inside. They eat food, they burn calories, that keeps them warm from the inside. Turtles don't do that. Lizards don't do that. Crocs don't do that. They all rely on external sources of heat to make their bodies warm. And so if a turtle sits on a nest of eggs, she's not going to keep it warm. That makes sense. She doesn't generate her own body heat like birds do.
Favorite fast food?
And Tim Innsman, 100 bits. What's my favorite fast food? Oh boy. Maybe like a grilled cheese from In-N-Out Burger? Or some stuff from Taco Bell? Yeah, I don't know. Thank you for the 100 bits there, Tim Innsman. I appreciate that. Yeah. And Bet Medler.
Massive jaws filled with razor-sharp teeth, Tyrannosaurus Rex was a terrifying sight.
Bet Medler isn't, though. Thank you for the 44 months of support, Bet. I really appreciate that. Thank you. For sustaining this science outreach online through your financial support. I really appreciate that. Good stuff. In-N-Out is hard to find outside California, right? We've got it in In-N-Outs in Utah and in Nevada. But yeah, it is largely a California thing. But yeah. Anyhow. Oviraptors may not have been able to conduct the whole body heat incubation thing as modern birds do, said Sue. Instead, these dinosaurs and the sun may have been co-incubators, a less efficient incubation behavior than that displayed by modern birds. Yet the combination of adult incubation and ambient heat source, perhaps a behavioral adaptation associated with the evolution from buried to semi-open nests, isn't necessarily worse. Modern birds aren't better at hatching eggs. Instead, birds living today and oviraptors have a very different way of incubation, or more specifically, brooding, Yang pointed out. Nothing is better or worse, it just depends on the environment. And check out their experiment here. This is really cool. So this is their simulated oviraptor body, and then the eggs are underneath this. So with thermometers in each of these artificial eggs, they're able to kind of measure how hot or cold they get when they're in different parts of the nest, and this is neat. You know, I can use this as an example when somebody says, well, you know, paleontology, it isn't really an experimental science. Nonsense. Is this not an experiment? Anywho. Yeah. And thank you, Goldenak, for those 100 bits there. I appreciate that, Goldenak. Thank you. Excellent. For those 100 bits. And, we've got a hype train kicked off here. Well. We're still, only 1/15 of the way to our sub goal for the week. And we're almost halfway through the week, so we're well behind. Maybe we'll get some more gift subs. Or more people subscribing. Yeah. Yeah. And Gimplex says, how many eggs were in an Oviraptor clutch? It would depend.
Dinosaurs hold a special magnetism for children.
Thank you, Oliver Sutton, for those 18 months of support right there. Really appreciate that. Thank you. Helping us along. With the hype train, at least. Good stuff, good stuff. And Gimplex says, since most birds only lay a couple of eggs, I wonder if survival rate was less important to oviraptors. So here's the thing, Gimpleg, is that when we're thinking about non-bird dinosaurs, it's important to think about bird phylogeny today. Let's look at birds on our tree of life, and you'll see what I mean. Birds evolved from dinosaurs, from theropods, not too far from the oviraptors. Oviraptors are pretty close relatives of birds. Thank you, Claire Burr, for gifting Yar the Goose. You didn't have to do that, Claire. Thank you. With our new alert. Good stuff. Appreciate that, Claire. Yeah, so we know birds evolved from dinosaurs. And when we're looking at birds, we've got the neonates, which are... This is the vast majority of bird species. We've got, how many species? Over 9,000! Some would say over 10,000. But then you've got this other group, the paleonates. These ones split off earlier, and in some ways, they might be more similar to dinosaurs like Oviraptor, and Heyuania, and Citipati, and Velociraptor, and Allosaurus, and all these guys. So, if we're trying to draw some inferences about how these dinosaurs may have laid their eggs and built their nests and stuff, your first stop shouldn't be the neonates. You should probably look at these guys first. As they split off earlier, they might be more non-avian dinosaur-like in a lot of their biology. And these guys do interesting things with their eggs, and I do mean guys. Because yes, it's the females who lay the eggs, but it's dad who sits on the nest and takes care of the babies. So with male and female ostriches... Oh, hang on. Yara the Goose, thank you for the gift sub there. I appreciate that very much. You're paying it forward. I appreciate that, Yara the Goose. Thank you. Superb. I appreciate that, Yara. Holy cow. Thank you. Excellent. So, ostrich males and females. The male is the one who takes care of all the babies. And the way that this works is a bunch of different females will visit him. He builds a nest. He shows off to the females, and a bunch of them visit him. They breed with him, and then they lay their eggs in his nest. So he's incubating the eggs for a bunch of different females. Each of them might only lay 1 or 2 eggs. But he's still got a bunch of eggs in his nest. Maybe that's the same situation with our oviraptors, you know? There's certainly a lot of eggs in there, in these nests. You know, you can get a whole bunch, and it seems like maybe way too many for one dinosaur to lay. It could be the same situation as happens with our modern birds. Our modern ostriches, emus, cassowaries, rheas, they all do this. Tinamous do as well. So maybe this is dad sitting on the nest, and there's a bunch of different moms all laying their eggs in his nest, you know? So that might be what's going on here with these guys. Linear says that makes total sense. I'm glad. And Slightly Average American says, hey, hey. Hey, hey, right back at you.
It's a paleontologist version of heaven.
And that's the Gobi Desert right there, where these fossils are from. Snake65, double X, thank you for the follow. Welcome. Good to have you here. Yeah. And how has the likelihood of being easily fossilized like burrowers affected the current understanding of the commonality of different species? Yeah, so like preservation bias is what we call that, hey Key. Certain animals might be preserved more frequently than others. There might be a real bias in how they're preserved. It's one of those things you gotta think about, you know? Just because you find a certain kind of animal more commonly in the fossil record doesn't mean necessarily that it's actually much more common, you know? It just might mean that there's some sort of condition that makes it more easily fossilized. Or maybe it's even just easier to find when you're out trying to find fossils. It's bigger, or it's more flashy, or it's more distinctive. It's harder to overlook, you know? So you get preservation bias, and you get collecting bias, too. These are the things that we have to think about as paleontologists. So we are not misled. If that makes sense. Yeah. I have missed all the lighter-than-air skeletons. No, I mean, literally birds are like this, where, like, bird fossils are kind of notoriously rare. Because they've got very lightweight skeletons, they're very delicate. Often the bones are pretty small. They're less easily preserved than something like a turtle, you know? Excuse me. Turtles are often living in environments where they're already in a river or lake or something like that. So they're in a place that's it's easier to preserve them. It's easier to get them buried by sediment and permineralized and fossilized. And then when a turtle like this dies, it kind of explodes in slow motion. That shell can disarticulate. You can get hundreds of pieces of shell from the same turtle. They scatter all over the place, and then you find them. And these are pieces of fairly thick bone, so they're more likely to be preserved. You can tell that it's turtle shell. So, turtles are... they're maybe a little overrepresented in the fossil record, if that makes sense. You know what I mean? Does that make sense? Yeah. Oh, an interesting Pogo logo. That's where he casts glow under UV light. That makes a lot of sense. Birds can see in the UV spectrum. That's how their eyes work. That makes a lot of sense. Yeah. And Sabarina says, have you seen the Netflix Archie show? What's Archie? I don't know if I'm familiar with that term, Sabarina. Yeah. Anyhow. Oh, and then you got other things like in some geological formations, there's just eggshell everywhere. So that shows you that creatures like dinosaurs, turtles, crocs, lizards, birds, they're laying eggs there in that environment. But sometimes you get huge geological formations where you get almost no eggshell. And maybe it's because in that environment, you just have some chemical reason for why the eggshell is not being preserved. Maybe the soils are particularly acidic or something like that. And so eggshell has a tendency to dissolve. You know, these are the things you got to think about. Got to keep this stuff in mind when you're a paleontologist. Oh, an archaeology show. No, I don't really watch a lot of TV, and I'm not an archaeologist. I'm a paleontologist, so I don't know anything about archaeology. Yeah. Frankly, I haven't even had time to watch a lot of paleontology stuff lately. But yeah. Yeah. Anyhow. The team pointed out that their findings are specific to the reconstructed nest and are limited by the fact that today's climate does not resemble the late Cretaceous climate, which may have impacted the results. Oviraptors also exhibited a longer incubation period than modern birds. Yet the study advances our understanding of oviraptor brooding strategies through innovative approaches. It represents an important bridge between physics-based simulations and paleontological interpretations, potentially enabling paleontologists to investigate topics for which approaches were limited until now. It is also truly an encouragement for all students, especially in Taiwan, concluded Yang. There are no dinosaur fossils in Taiwan, but that does not mean we cannot do dinosaur studies. Love that. Here is a link to this press piece here. There you go. And here's the paper in the journal Frontiers in Ecology and Evolution. There we go. So we'll just look at this really briefly before we move on to our next piece of news. We'll see if we've got any pretty figures here. Here's how they built the model of the Oviraptorosaur's torso. Here's how they arranged the eggs underneath that model. Model periphery, core, periphery. Put the eggs underneath like this. It's pretty cool. There we go. Blanket, heating pad, periphery, core, air temperature measure. And here's how the eggs were arranged like that. This is cool stuff. I love an experimental approach to a question like this. This is neat. You'd love to see more of this kind of thing, you know? Pretty neat, pretty neat. Yeah, good stuff. Very cool. Very cool. All right. And Yara the Goose says, respect to paleontologists. Having so many questions and not enough answers would drive me mad, knowing we might never know or discover all the species that have roamed the Earth. I mean, we'll never know all the species that roamed our planet because not all of them will have been fossilized. There are countless species who evolved and lived and went extinct or evolved into something else, and there's no record of them in the rocks. If you're a species that arose and then went extinct in a non-depositional environment, in an area where you're just surrounded by erosion all the time and nothing's being buried in your habitat, what chance is there that you'll ever become a fossil, you know? I'm surely countless species for whom that situation applies. But that's the thing, like, as a scientist, you have to be comfortable with that idea of the unknown. Comfortable with the idea that there are mysteries that will always exist. It doesn't stop us from trying to figure things out anyway, you know? In fact, it's exciting. Like, there is so much that is still unknown. The idea that we can find anything out at all about these creatures that lived millions of years ago, that's a cause for celebration. Like, that's a triumph that we can learn anything whatsoever about these creatures that lived such a long time ago. I get excited at that idea, you know? Like, what a privilege to be able to study these things, follow our enthusiasm and our passion, run experiments, come up with hypotheses, gather data, figure this stuff out. It's so cool that we get to do that, you know? And we're incredibly lucky that we have rich fossil record for so many different times and places in Earth history. You know? Yeah.
Rampaging in an unsuspecting world.
Uh-oh.
Living creatures from the dawn of time.
The Brutzler.
What havoc will they wreak? What lives will they destroy?
The Brutzler
What
and
devils
the
of panic and terror will they
like
create?
to read some stories.
Brutzler, how was your stream? I hope it was really good. Welcome back to Paleontologizing. How are you? How did your broadcast go? I hope you had a lot of fun. And today, the big sorting. What does that mean? I hope it was big and I hope it was good, I guess. I appreciate you bringing everybody over, Brutzler. Thank you. My name is Danny, for anybody who's new here. For anybody who's not new, my name is still Danny. And I'm a paleontologist. I work mostly on dinosaurs. And here's a quick little channel trailer to introduce you to what we're all about here on Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils. Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs. A limb bone from a new duck-billed dinosaur. I invite you to tune in and experience the adventure of fossil science. There you go. Welcome to Paleontologizing. And let me know if you got any questions, especially if you're new. Brutzler says, I started to categorize my electronic parts in a database. Think R&D, research and development, about 10%, and now there are 71 different types in the bank. Thanks for the shout out. You bet. Thank you for the raid, Brutzler. I really appreciate it. Well, you came in at the perfect time, because we're doing some fossil news right now. I'm trying to catch up to a bunch of new publications and discoveries from the past month, really. And we've got this. The Wheel of Fossil News. If somebody wants to type in !spin, just for fun, it doesn't actually spin the wheel. I spin the wheel, but you could do it anyway. There you go, Claire. Let's see what we get next. Excuse me. Ooh, a quick one. Cuban nightjar fossils. Cuba actually has some really cool fossils. A lot of endemic species, creatures that live nowhere else. Excuse me. Need some water. We don't have a press piece for this one, but it is just a new paper. Here we go. Nightjars are some of my favorite birds. They're really cool. And we've got some fossils just published of some nightjars from late in the age of mammals. Let's take a look at that. Nightjars, Yara the Goose, yeah. Yeah. Also known as nighthawks or goat suckers. I love the transformation that these birds do. Where they can go from like, oh, don't mind me, I'm just a lump of dirt on the ground. They're so well camouflaged when they're on the ground. They sleep on the ground oftentimes. Like this. This is a standard winged nightjar. Super well camouflaged. But they're called nightjars because they take off into the night and they scoop up different bugs. They eat them in flight. And they're really beautiful in flight, too. This reminds me of, so this is, I think, a North American nightjar, maybe? I see these in the field when I'm out digging dinosaurs, like, before I go to bed. You see and you hear these, and they're so cool. But, yeah, those stripes remind me of, the invasion stripes on Allied aircraft in Europe in World War II. So, like, mid-1944, if you're part of the great Allied invasion of Europe, trying to liberate France and other countries, you would have these stripes painted on your aircraft like that so you don't get shot down by friendly fire. That's what these remind me of. They're so cool. Nightjars. And I didn't know that was their English name. Fun, says Yara the Goose. Yeah, let's look them up on our Tree of Life. Nightjars. Yeah. So we've got 91 species today. That's more than I would have guessed. Pretty speciose group. They're really cool. And I love the noises that they make, too. I've talked about this many times. I'll talk about it again, and I'll show you. This is really cool. One of my favorite sounds in the field is the call that they make. And then listen, because they'll also make kind of a honk noise. Listen. Do you hear that? Yeah. What's really cool about that noise is that they're not making it with their mouth. That is a mechanical sound that they make because they dive down, and then when they pull out of the dive, they spread their wings, and the spreading of their wings kind of breaks the air in such a way that it produces that sound. It's almost like the mini version of a sonic boom or something like that. So cool. How neat is that? Oh, man. Really, really cool stuff. Yeah, so you might even be able to see them in this video, too. There we go. Here, I'll turn the sound up so you can hear a bit better. Here he is flying around. Watch, diving down. How cool is that? How cool is that? No,
or cause case people.
YouTube. Nighthawks, part of the nightjar family. Dive it down. How cool is that? Anyway, nightjars. So we've got a new paper. I think this just maybe came out today. Here is a link. It's in the journal Zootaxa. There's no press piece for this, but cool that we've got some new... Oh no! Ah!
Access denied.
Oh well. We won't be able to look at the paper. But anyway, nightjars are predominantly nocturnal birds that are rare in the fossil record. Based on materials from the Upper Pleistocene and Holocene deposits of El Abron Cave, it's very close to being a swear word, El Abron Cave, western Cuba, 2 species of nightjars have been identified. The likely extinct Siphonoris daiquirii, interesting, and the modern Cordelias gunlackii. Wait, what do we mean likely extinct?
This is the horizon, which marks the extinction of the dinosaurs.
Is it not known whether this?
Below this level, and out in here, there are dinosaur fossils.
Mechanism
Above this level, in these rocks, there are
Mechanism.
no dinosaur
Below that
fossils. So
level.
I'm actually
Let's talk
standing on
dinosaurs.
the level that marks the extinction of the dinosaurs.
Thank you, Mechanism, for your raid. Welcome to Paleontologizing. How are you doing? It's wonderful to have you here. I hope your stream was a good one, and I appreciate you bringing everybody over. Welcome, welcome. Yeah. Good stuff. Good stuff. Mechanism was doing some makers and crafting. Well. Excellent. We're going over some new scientific papers, trying to catch up on some fossil news here. And kookaburra is probably what you're thinking of, Claire. Kookaburras are a kind of kingfisher, so they're not closely related to nighthawks. So here's nightjars, aka nighthawks. The kookaburra is a kind of kingfisher. They're over here. Maybe you're thinking of frogmouths, Claire, because frogmouths are related rather closely to nighthawks. Yeah. There we go. Yeah, like the tawny frogmouth. Exactly, Mechanism. Yeah. Frogmouths. Including the tawny frogmouth, who sometimes looks like a tree branch, but very often looks like a Muppet. They are just effortlessly expressive. Yeah, it's pretty nuts. Just their range of facial expressions. Yeah. Yeah. Anyhow. Typically heads to the branch office. There you go, Cacklinsworth. Yeah, true. Anyway, so this is fun because this is one of these, like, unheralded papers in paleontology. You've got lots of little publications like this coming out all the time that help build our understanding of the history of certain groups of organism. So now we've got some fossil nightjars from Cuba. So this paper isn't going to get a lot of attention, not a whole lot of people reading it, not a whole lot of people hearing about this in the wider, in wider culture, but I like to give it some attention here on stream. So again, here's a link to this, and yeah, it'd be cool to do a stream about fossils from Cuba at some point. Maybe I'll do that sometime soon. But, neat stuff. Yeah. And dollar bread. Oh, interesting, Rushman. Yeah. And Mayor of Spaces, I think the IUCN only declares something extinct after so many decades of no confirmed sightings. So, likely extinct probably means they haven't crossed that threshold yet. That would make sense. Let's look at that, Mayor of Space. Let's find that genus and species. Look it up. Siphonoris daiquirii, rather. The Cuban paraque, also known as the Cuban poorwill, is an extinct species of nightjar. Cuba. I guess it's only known from subfossils. Named in 1985, shoot. So it was found in cave deposits. Because of the cryptic nature of paraques and other nightjars, Olsen considered it possible that the species might not be extinct, though there have been no confirmed records of living birds. So, let me ask you this, chat. Would this qualify as a cryptid? Extinct birds. Kinda, says Claire. Rainstorm First says yes. Don't cryptids have to not be recognized by science? I don't know, Mayor Space. That's an excellent question. In my opinion, this is the sort of thing that cryptozoologists should be investing time and attention and effort into. Like, is this bird extinct or is it not? I find that really fascinating. Unlike your Sasquatches or your Yetis or your Lake Champlain monsters, we know this creature did exist. Is it still around? Somebody should figure it out. Anyway, if you're interested in this kind of topic, I can recommend a book to you. Here we go. If you'd like a scientific perspective on cryptozoology, I highly recommend this book by paleontologist Darren Naish. And he does kind of explore the topic here. What is cryptozoology? And if there's a possibly recently extinct animal that could still be around, would that be considered a cryptid? Let's see. Yeah, cryptozoology, science or pseudoscience? Is cryptozoology really a part of zoology? So the answer to a lot of these questions is like, which I think is really fair. Yeah. Were the okapi, the mountain gorilla, the kapunji, the great peccary, and the Burmese snub-nosed monkey, were they all cryptids prior to their official discovery? And were the scientists who investigated initial reports of these animals doing cryptozoological research? And should those scientists be regarded as cryptozoologists? The majority of individuals concerned would say no, whereas people whose main interests lie with cryptozoology would say yes. In part because they want the subject to be taken more seriously and to be considered on an equal footing with the formally accepted branches of zoology. A tidy solution to this problem isn't obvious. Ideally, it might be wise for cryptozoology to be considered a branch of ordinary zoology that specializes in the collection and interpretation of anecdotal or apocryphal data. Many people interested in cryptozoology might well prefer this definition to be the one that ultimately becomes favored. Anyway, I would highly recommend this book if you're interested in this kind of thing and want to think about it from a more scientific kind of perspective than like a Discovery Channel, nonsense reality television kind of angle, So, good stuff. I want to bring Darren Naish on for an interview at some point, if you'd like to do that. Particularly to talk about this kind of thing, and also to chat about leatherback turtles. I think that would be really neat. But yeah. I might have to book a trip to Cuba one of these days. I would love to as well, Buggo Wuggo, but we'll see. I also really want to go back to Puerto Rico. What's the phrase about those two countries? Yeah. Cuba y Puerto Rico son de un pájaro las dos alas. Cuba and Puerto Rico are two wings of the same bird. I think it's a beautiful phrase. They share a lot of history. Like, genealogically speaking, it's like, populations of both islands are very similar in a lot of ways. It's, yeah. Anyhow, and it's not to get too depressing or anything right now, but it is absolutely shameful and abhorrent what the United States is doing to Cuba right now. Where thousands of people are dying because of the oil embargo that the United States has placed on that island right now. People are starving. People are dying in hospitals. Babies are being asphyxiated because when the power goes out, because there's no oil, the ventilators shut off, and it's just like the United States is essentially committing what amounts to a genocide against the Cuban people right now. And as an American, I am deeply, deeply ashamed of the leadership of my country at present, and that's all I'm going to say right now, so I don't get too hot about this. But holy cow. Anywho, they've got cool fossils in Cuba, and it'd be nice to see this get some more attention. Anyhow. And Conrad with a K says they found some Takake in Fjordland after calling them extinct for half a century. We have another news story about a similar thing. We'll see if that gets picked today. But, in fact, actually, let's do that right now. We're gonna cheat here a little bit and not even bother about landing on this with the spinner. Let's, just take that off of here. Two marsupials not extinct. Let's talk about that. This is exciting stuff. Two species of marsupials thought lost for 6,000 years found alive in New Guinea.
The age of reptiles.
Kit Psychotic, thank you for the follow. Welcome to Paleontologizing. Good to have you here. In the remote rainforests of New Guinea's Vogelkop Peninsula, scientists have spotted two marsupial species, the pygmy long-fingered possum, Dactylonax cambuia, and the red-tailed glider. Oh man, another gliding marsupial? This is so cool. Tos ayamarwensis, believed to have been lost for roughly 6,000 years. Excuse me. These discoveries suggest that New Guinea's forests may still shelter remnants of an ancient faunal world. Really exciting stuff, and I betcha, I hope that this team has put together like a video press release here. Let's look for that. Pygmy long-fingered possum. I'm looking for... This is going to be a little bit too long. Also, anytime I see somebody like in a thumbnail looking surprised and clickbaity with headphones on, I'm like, oh boy, is this some sort of nonsense podcast thing? That's nuts. This isn't bigger news. Let's try this. Oh, no, hang on. That's going to be too long. It's an interview. Let's take a look at this. Yeah.
Two marsupial species thought to be extinct for over 7,000 years have been rediscovered as living animals. Bishop Museum scientists announced the pygmy long-fingered possum and the ring-tailed glider were found in New Guinea. Both are fairly small animals that live in forest habitats, and up until now, only known as fossil records.
Before this, we only knew these animals from teeth and bones in caves, fossils. This is a startling discovery because it shows us these animals are alive and well.
The pygmy long-tailed possum is the smallest living striped possum with black and white stripes similar to a skunk, while the ring-tailed glider is a gliding possum that lives in the hollows of large trees.
Very cool. And that's, I feel like a lot of people are not familiar with gliding possums. I mean, that alone is really cool and newsworthy. Are gliding possums and sugar gliders the same thing? Here, let's take a look at this from Animal Fact Files. And, yeah, aren't those... So they're primarily nocturnal, I presume.
Files, we're discussing feathertail gliders and feathertail possums. There are 3 living species in this marsupial family.
And now there's probably one more with this new discovery.
And these species are divided into 2 separate genera. One species, the feathertail possum, exists in New Guinea, while the other 2 species, the feathertail gliders, are only known to live in eastern mainland Australia. They get their common name, feathertail, from the unique appearance of their tail. It looks very much like a long tail feather from
a sugar girl, yes.
The hairs lining the side of this flat tail are stiff, which keeps it rigid while balancing on tree branches or gliding. In this way, it acts like a rudder. Although not fully capable of flight, feathertail gliders do exactly as their name implies.
They glide. They fall with style.
Flap of skin between their elbows and knees on both sides of their body. These marsupials can soar more than 65 feet, 20 meters between trees. They live in both...
I bet most of you in chat can't even glide 20 meters between trees. And this little critter can do that, you know? Get on their level, chat. Claire says, not even close. Well, you could do a lot of other things, though, Claire, to be fair.
Soar more than 65 feet, 20 meters between trees. They live in both wet and dry forested areas and have serrated toe pads.
The bushes. There you go, Turner. I remember seeing that in the theater. These critters could do it, though.
Them grip, even on smooth surface trees such as eucalyptus. Feathertail possums, on the other hand, do not have that skin flap and are not able to glide, but they're still experienced trapeze artists in the trees. Trapeze artists, perhaps?
Oh boy.
The feathertail on all species can hold onto branches, and these tiny mammals are such excellent climbers. They can cling to a smooth, vertical pane of glass.
Petrodactylus says, I love those pink parrots. That was a galah, right? Which I learned how to pronounce that live on stream from some Aussies in the chat. Galah. Oh, that's a galah. We have too many other news stories. I'm not going to get into the galah video, but it was, oh man, it was good.
In the trees. Trapeze artists, perhaps?
Oh boy.
The feathertail on all species can hold onto branches, and these tiny mammals are such excellent climbers. They can cling to a smooth, vertical pane of glass. That's a grip to rival geckos.
That's impressive. They're probably the only mammal that can do that.
When describing them as small, we truly do mean small. Feathertail gliders...
I bet most of you in the chat are not even this small, where you could fit on a person's thumb like that, you know?
Are some of the smallest living gliding mammals.
I'm sorry, I just have a tendency to compare chatters to other critters, you know?
Maybe that's not a healthy impulse, but maybe it helps us appreciate how extraordinary these animals are, you know?
Really do mean small.
And petrodactyls, I've met you in person. Your hands are not that small.
Feathertail gliders are some of the...
Extinction is no shame, no sign of disgrace or failure. In fact, in a world full of changing environments and occasional catastrophe, all species eventually
Thank you for the continuing education, Danny.
Extinct. Thank you, C-152 Flyer, for helping me continue this education. With your 7 months of support, with your Prime there. Thank you, C-152 Flyer. So you're a flyer, these are gliders. It's cool that you've got something in common there. Anyway, I appreciate you, C-152. Thank you.
Seeing them as small, we truly do mean small. Feathertail gliders are some of the smallest living gliding mammals, averaging less than 6 inches, 15 centimeters in total length. They're mouse size. Feathertail possums are not much bigger, measuring around 10 inches, 25 centimeters long as adults. These marsupials appear darker across their back with a creamy to white underside. The possum has black stripes that run vertically down across its eyes, while the gliders have darker eye patches. Feathertail gliders and possums are rarely seen, but that doesn't mean they're not around. Much like raccoons, these small mammals are nocturnal, limiting their activity to nighttime. Feathertails are pollinators. They consume
A pollinating mammal. When we think of pollinators, you know, what are the critters you think about, chat, when you hear the word pollinator? What are the animals that are typically... Who rushes to mind when you think of pollinating animals? Bees, says Puggo Wuggo. Flies, says Conrad. Very good. Bees, says Peppercat, yeah. Yeah, bumblebees. Butterflies, Yogurt Garrel. Yeah. Yeah. You know, people really like pollinators. It's you know, we look at he's like, yes! Pollinators! We love them. But I haven't seen anybody mention this critter yet. Bats. Bats are also very important pollinators. Yeah. And sometimes they're just covered with pollen, like this one here. That's so funny. But I don't know if they have a lot of bats in New Guinea. They might. But these guys act as pollinators too. Just shoving their little snoots into flowers and what have you.
Around. Much like raccoons.
Hummingbirds. There you go, Bitsem. Yeah, yeah. But yeah, we often think of pollinators as being very small animals, and they typically are. It's crazy that like this fits into like the little pollinators kind of category. This is a mammal. It's almost Mesozoic in its scale, if we're talking about mammals. Yeah.
Are rarely seen, but that doesn't mean they're not around. Much like raccoons, these small mammals are nocturnal, limiting their activity to nighttime. Feathertails are pollinators.
Okay.
They consume nectar and pollen, as well as sap, fruits, blossoms, and even honeydew, which is a sweet liquid produced by insects such as aphids. The feathertails also eat...
That's so funny that they're so small that they're like licking aphids to get their... I love them. I love them.
Honeydew, which is a sweet liquid produced by insects such as aphids.
You got to be pretty small to be drinking fluids produced by aphids. That's so funny.
The feathertails also eat insects.
And there's a bottlebrush tree. We have these in the Bay Area. Introduced. They're all over San Francisco. Some of my neighbors have these. But I think they're from Australia or New Guinea originally.
And other invertebrates. An arboreal lifestyle helps protect these mammals from predators, but they're still taken by ravens, owls, snakes, monitor lizards, sugar gliders, and ghost bats.
Whoa.
What's more, feathertails are threatened by introduced animals such as foxes and domestic cats.
Yeah.
That being
Keep your cats inside, especially if you're in someplace like New Guinea or Australia.
said, they seem to benefit from agricultural practices that disturb forest habitat, as long as there is enough vegetation for foraging above the forest floor.
Huh.
Feathertails live in small groups of 2 or 3, spending their days resting in tree hollows. They take multiple partners when breeding, and it's not uncommon for a litter to be fathered by different males, or for a female to feed young that she didn't produce. The babies are kept in a pouch that faces the mother's rear end. They'll stay here for just over 2 months before
Are they wiggling around in her pouch there? Is that what we're looking at?
venturing out. They're
Wild.
weaned around 100 days old and are nearly adult-sized by 5 months of age.
Yeah, there's baby poking
Although
out.
they're small, feathertails can live for more than half a decade in the wild. Much like the Virginia opossum, feathertail litter sizes are limited by their nipples. Feathertail gliders are most frequently observed with 4 nipples, while feathertail possums more commonly have only 2. Besides help in child rearing, another benefit of group living is that feathertails can huddle for warmth. When the temperature reaches 50 degrees Fahrenheit, 10 degrees Celsius, they enter a low energy state, which helps them stave off starvation. This state becomes even more effective when they huddle together.
That's adorable.
There's more to learn over on the AFF Patreon. Our supporters, Dad.
Good stuff. Thank you, Dad. If you want to support Animal Fact Files, just giving them a thumbs up or a subscribe there on YouTube, I'm sure it would be appreciated. But good stuff. So those are species that we know about already. We've got 2 brand new ones. Exciting stuff. Let's see here. There is a longer interview. I'll look at the beginning of this and then I'll give you the link to it. Let's start it off at least. And there you go, Puggo Wuggo. I think you're correct about that.
Welcome to the World, the Universe and Us from New Scientist. I'm Dr. Rowan Hooper. Now, 2 marsupial species, including one that's a completely new genus of gliding mammal, have been found alive in New Guinea after it's thought they've become extinct at least 6,000 years ago. Now, the discovery is significant enough that one biologist we spoke to said it was more important than finding a living thylacine in Tasmania, a living Tasmanian tiger. One of the new species is a marsupial glider. The other is the pygmy long-fingered possum. And we're going to find out more about this discovery today. To talk us through it, I'm joined by the leader of the team that confirmed this discovery, Tim Flannery at the Australian Museum in Sydney. Tim, thanks for coming on the
I know
show.
that name.
Can you maybe start by telling us
Paleontologist,
how this
Tim
research
Flannery.
started? You know, were there rumours that there were these unknown species in the jungle?
So here's the thing is that I was talking earlier, like when we started this whole fossil news segment on today's stream, I said a lot of this is going to dip away from fossils and into living taxa and modern conservation and all of that, but it's all a gradient, you know? As a paleontologist, I'm not just interested in extinct animals, especially not even just dinosaurs, but all kinds of different critters, living and extinct, because there's this grand continuum that goes from the origin of life on Earth up until the present. And when we as paleontologists are studying extinct organisms, often we're looking at modern animals for clues. We're trying to figure out who's related to whom. It's like, it's all part of one great big tapestry like this, you know? And this is an example of that, you know, this beautiful confluence and integration of modern zoology and fossil science and conservation. This is cool stuff.
In Sydney. Tim, thanks for coming on the show. Can you maybe start by telling us how this research started? You know, were there rumours that there were these unknown species in the jungle?
Well, the research really started back in 1999 when a colleague of mine, who's very sadly deceased, a man called Ken Aplin, was examining archaeological remains from a cave deposit in West Papua. And he came across two tiny fragments of bone. I mean, really, they would barely fit on the nail of your little finger, these two bits of bone. And he said, on the basis of those two bits of bone, that one belonged to a gliding possum of a subfamily which was totally unknown from New Guinea otherwise. And the other one was a very distinctive species of long-fingered possum. And at the time he showed them to me, he was a dear friend of mine. We did our PhDs together and all of the rest. And Ken was a genius. He was one of the very few geniuses I've ever known in my life. He showed them to me. I was dubious. You know, I could see what he was saying, but I thought...
This is really cool because when you get to know paleontologists, sometimes you encounter people where they are so knowledgeable about a particular group of critters that from the tiniest little fragment, they'll be like, oh yeah, I know this. You know, this is part of the midshaft of the fibula of this particular species. And you're like, how in the world can you tell that from this tiny little fragment of bone that might be like the size of a grain of rice? But they know it based on the cross-section. They know it based on the surface texture. They know it based on the density, maybe. Like you start to just develop a feel for these things over time. And you never completely trust that feeling. You always want to be able to verify it. You want to find more of it, all of this stuff. But, like, you do develop a feeling for it over time. It's kind of like if you're talking to somebody who maybe works in retail, or they work at a cash register, and they see a lot of cash. They might be able to tell you, oh no, don't accept that bill. That's counterfeit. That's fake. You go, how can you tell? And they go, well, I don't really know, but something about it just looks really off. You see enough of these things and you just develop this feel for it over time. It's kind of like that, you know? You sort of develop this almost sixth sense for it. When you see enough fossils or enough bones or shells or whatever, you start to grow this sort of mental model, and you can just kind of feel when something's off. Or whether it's this species or that species, that kind of thing. You know? Yeah.
And Ken was a genius. He was one of the very few geniuses I've ever known in my life. He showed them to me. I was dubious. You know, I could see what he was saying, but I thought, we've got two fragments from a cave full of hundreds of thousands of bone fragments. So what are the chances? So I filed it away in the back of my mind. And then probably 12 years later, 12 to 15 years later, Ken was passing through the University of Papua New Guinea, and he stopped in to examine the teaching collection, which is a sort of a sacrificial collection. And among the things there that students, you know, do all sorts of gruesome things to, was a specimen that looked different to him. So he borrowed it, brought it down to Sydney, and realised that in fact it was a specimen of his long-fingered possum, which had somehow got into a teaching collection in a different country. We don't really understand how, but it's what happened. So that was the beginning of the journey. And for the second species, the first real evidence we had that it may still be alive arrived a week after Ken's death, tragic death in 2022, when a colleague of mine, Chris Helgen, was sent a photograph by a plantation worker of a really unusual animal. It was one of about 50 photos sent, the only one of interest, really.
So again, this is like, is this cryptozoology, you know? You get a photograph from a far-off place, and they're like, here's a new animal, a hidden animal.
And, you know, we put our heads together and we thought, maybe, could this possibly be...
It's just zoology, really.
You know? And the thought really was left there. I was very lucky. Later in that year, I went to West Papua to do some research, talked to people who seemed to know about that animal. I then sent a student to have a look a year later. Still no specimen, but interesting conversations with the locals. And then finally, a year after that, a local hunter sent a photograph to the student I'd sent there of an animal that he'd hunted, and it was the same thing as what was in the photo. A much better picture, though, of an adult animal, and we could very clearly see what it was. So that was when we really knew that we were onto something, that both of these animals were living. In the meantime, we got saw some more photographs of the long-fingered possum as well, taken by mammal watchers.
And you look at that, a long finger.
Saw some more photographs of the long-fingered possum as well, taken by mammal watchers in an area of West Papua. So by then we had good evidence that both of these animals, thought extinct for 6,000 years, were alive and well, or alive at least, in the forests of West Papua.
Can you tell us a bit?
Very exciting stuff. Really, really cool. Here is a link to that video. So the interview goes on for a while. I want to watch the rest of this later. We're almost 4 minutes in. It goes to 17 and a half minutes. It's like, if you want to watch that afterward. And then here's that press release here. From just last week. The discovery of the two species thought to have been extinct for thousands of years is remarkable. The findings underscore the critical importance of preserving these unique bioregions and the value of collaborative research in uncovering and protecting hidden biodiversity. Previously known from Pleistocene fossils in Australia and from Pleistocene early Holocene fossils from New Guinea, the pygmy long-fingered possum and the ring-tailed glider have been found in isolated lowland forest habitats on the Vogelkop Peninsula. Its forests may shelter yet more hidden relics of a past Australia. Really cool. Referred to locally as the Taus, or Taus, by some Tambrau and Maibrat clans, the glider is a sacred animal, said Rika Corain, a Maibrat woman. Considered a manifestation of ancestors' spirits and central to an educational practice referred to as initiation. We worked very carefully and collaboratively with Tambrau elders, and identification would not have been possible without cooperation with the traditional owners, and this connection has been essential for ongoing work. I'm very proud that Papuan researchers contributed to these landmark discoveries, and want to thank the people of the Misul, Maibrat, and Tambrau regions who supported us in the field, added Dr. Aksamina Johanita, researcher at the University of Papua. A paper describing these discoveries was published on March 6th in the records of the Australian Museum. There's the paper right there. And it is open access. Beautiful.
Access granted.
Here's a link to the paper, if you'd like to look at this yourself. Really cool to have a fossil critter show up alive. Two fossil critters show up alive. Yeah. Well, they were thought to be all gone, but it turns out they have survived
To this day.
to this day. There's our, turns out not extinct, I think, long-fingered possum. Nice illustration here. Is this our gliding one? Looks like it might be pretty glidey. Maybe not. There's skeletal remains of these critters. Yeah, very cool. Preserved specimen. Really neat. Really, really neat. Yeah, something has survived. There you go, Death Soares. Yes, yes. Oh, man. And excuse me, Heiki says it almost looks like it's on its path to develop bat wings. Almost. Although these guys have been, I don't know, being a gliding mammal is a pretty good way to go. Like, bats have all kinds of weird specializations that they do allow them to have powered flight, but it also puts a lot of constraints on you, you know? Like, it's not easy being a bat. These guys are doing pretty well just how they are. It would take a very different set of selective pressures to get them to actually evolve powered flight in the future. So I kind of doubt that's where they're headed, you know? Yeah. But when we're thinking about the evolution of bats, they must have had some kind of an intermediary stage. You know, where they started off as glidey critters and then later developed powered flight. We still don't know how that happened with bats, because they're so specialized. But maybe they did have almost like a gliding possum kind of phase at some point. Something like this. You know? Yeah. Anywho. Yeah. If that makes sense. Anywho, do you think we have time for... Yeah, we've got time for one more spin of the wheel here. Let's do it. Somebody want to type spin into the chat? Doesn't actually do anything, I just think it's fun. There we go. Ho ho ho! Another surprise today. Giant carboniferous bugs not the result of heightened oxygen levels? What? Well, well, well. This is new as of yesterday. That wasn't on my 2026 bingo card. Exciting, right? Giant prehistoric dragonfly-like insects may not owe their size to oxygen. Study. This is cool because this is actually one of the critters that we have on our logo for Paleontologizing. See if you can pick it out. Ready?
Astonishing. Simply astonishing. One of the most singular specimens I've encountered in all my distinguished career. But enough about my work. What did you want to show me, Lee?
Koha27, thank you for the follow. Welcome to Paleontologizing. Did you see it there? This is critters like Meganuera and their kin. These big dragonfly-like insects who could get as big as, I don't know, like an owl, a hawk, something like that. They were big critters. And hi to you, Koha. Thanks for being here. Thanks for the follow. Yeah. So the oxygen thing is so popular in pop culture. Exactly, Deathsaurus, yeah. Yeah. So what's the deal here? We do know that there were these giant insects during the Carboniferous, insects and other arthropods. Now you had millipede-like critters as long as a Volkswagen Beetle. Or a Toyota Prius, sure. You had dragonfly-like insects as big as an owl. You had scorpions that were like a meter long. These lived long before the dinosaurs. In environments like this, these ancient coal swamps, around about 350 million years ago, give or take. An interesting time on our planet. Forests were kind of going nuts for the first time. Land plants had evolved and spread throughout the continents, and taking advantage of these new environments, these giant arthropods. We do have some evidence that oxygen levels were higher back then, because you have all these gigantic trees, and some of them are really weird, where they're like giant horsetails and plants like that are like 100 feet tall, like 30 meters. They're producing a ton of oxygen. So that's one idea for how these arthropods got so big. But this new study says, no. So let's take a look. Long thought to be fueled by increased atmospheric oxygen concentration, enormous griffin flies, they're not actually dragonflies, we call them griffin flies, from the Carboniferous period, 300 million years ago, may have grown large for other reasons, according to new research led by University of Pretoria paleontologist Edward Snelling. Take a look at that. Huge. I hope this is accurate. Part of this almost looks like it's like AI generated. I hope it's not. You know, who's the artist here? This is a little troubling. I'm not gonna let that ruin this though. I really hope they didn't just use some AI dog water here. Some slop garbage. There's so many different paleo artists that you could hire to do this kind of thing. People who really need the work. But anyway, let's just get into it. In the 1990s, scientists suggested that a period of high atmospheric oxygen, around 300 million years ago, coincided with the occurrence of giant insects. They proposed that a higher demand for oxygen and larger body sizes of giant insects ought to require a higher atmospheric oxygen concentration. This made sense because insects obtain oxygen through their unique tracheal system, which is a branching tree-like system of airways leading to their ends, the tracheoles. So they don't have like a kind of lung system like we have. We breathe through our nostrils. Instead, with them, they're breathing through different body parts, and in some ways it's less efficient than the way that we breathe. Oxygen must move by diffusion down concentration gradients through the tracheoles to fuel the flight muscle cells. Researchers reasoned that a flying insect of such gigantic proportions could not exist now, because the level of oxygen in the present atmosphere is too low to support the high demand for oxygen in the flight muscles. In a new study, Dr. Snelling and his colleagues used high-powered electron microscopy to assess how body size affects the number of tracheoles in the flight muscle. They found that the space occupied by tracheoles in the flight muscle is typically only 1% or less in most species. And this observation holds when the relationship is extended to the griffin flies. This suggests the flight muscles of insects are not constrained by atmospheric oxygen levels, as they could easily add tracheoles in the muscle, since they take up so little space. Interesting. Okay. Huh. So if atmospheric oxygen really sets a limit on the maximum body size of insects, there ought to be evidence of compensation at the level of the tracheoles, Dr. Snelling said. There is some compensation occurring in larger insects, but it is trivial in the grand scheme of things. By comparison, the capillaries in the cardiac muscle of birds and mammals occupy about 10 times the relative space that tracheoles occupy in the flight muscles of insects. So there must be great evolutionary potential to ramp up investment in tracheoles if oxygen transport were really limiting body size. Interesting. Okay. The new data definitively show that diffusion in the flight muscle tracheoles cannot provide such a limit. Scientists will have to look elsewhere for why these giants existed. If oxygen does not limit maximum insect size, if that's not what keeps insects small today, a lack of oxygen, then perhaps other culprits are responsible for the small size of insects, such as predation from vertebrates or biomechanical support limits on the exoskeleton itself. Huh. Interesting. Puggo Wuggo says they were bored and decided to grow bigger. It's probably that these critters didn't have competition from any other flying animals. There were no birds. There were no bats. There weren't even pterosaurs at this time. Insects were the only animals that could fly during the Carboniferous, and they didn't have to worry about being snatched out of the air by other animals. So maybe that's part of it. It does make a lot of sense because it's not just during the Carboniferous that you had giant griffin flies and things like this. I think their heyday may have actually been the Permian period later on. Yeah, here we go. So you get critters like this during the Permian. So, here. And hello, sweetie pie. How are you doing? It's good to see you. So, we've got the Carboniferous period here, and then after that we have the Permian. And then what happens after the Permian? You start to get other critters evolving flight. In the Triassic period, you get the evolution of the pterosaurs. Suddenly, you've got competition in the air. Maybe that is limiting the size of insects ever since. When you have other critters flying around who might eat them, it makes sense to get smaller. You know? This would make a lot of sense to me. Here we go. Yeah. Watch out, dragonflies. And actually, this is not quite what I was looking for. Trying to find you this clip from Walking with Dinosaurs to help illustrate this point. That at one time, dragonflies were the biggest predators in the air. And then they were usurped. Here we go.
As the weeks of the dry
Triassic period. Get wrecked, bugs. Sorry. Maybe that is why you get giant dragonfly-like critters disappearing. It makes sense, timing-wise, because we have them in the Permian. By the time you get into the Triassic, no more. Everybody's downsizing. Oh, yeah. Yeah. And is there an animal named Pterosaurus? Not that I'm aware of, Puggo Wuggo. I don't think so. Yeah. Oh. What are you doing, sweetie pie? I wish I could give you some treats. I'm sorry, I'm not supposed to do that anymore. You got allergies. You got allergies. Maybe we can keep some of your food up here at some point, so that I can give it to you. But I'm not supposed to give you any treats anymore. I'm sorry. I'm sorry. I know. I'm sorry. I know you're not happy about this development. But it's doctor's orders, you know? Yeah. Yeah, it is. I'm sorry. I don't want you to get scabs in your ears and stuff. And Jamira, this is a new development as of like a few days ago. Lordy took Sweetie Pie to the vet, and the vet's like, yeah, you gotta stop giving her treats. That might be what's causing her allergies. So we're still in the process of figuring this out. But, yeah. Anyhow. Interesting finding here, and this is really disappointing. Yeah, Petrodactylus was saying... very much leaning toward image being AI. Did reverse image search, can't find it anywhere other than this article. Noticing weird artifacting and weird stuff going on with the limbs. So, yeah, 1, 2, 3, 4, 5. It very well might be that,
Ew!
Yeah, this is some AI slop. I don't want it to be, but it very well might be. Ugh. Anyway. We can look in, well... Do we have... Well, no, unfortunately it's in the journal Nature, so,
Access denied.
Yeah. I'm not about to spend $39.95 to purchase a PDF. And I don't currently have institutional access to this journal, so I guess that's that. Ending on a sour note here with that. Oh well. Should we do one more spin of the news wheel here? I think we should. Today I'm grateful for birds so our insects stay the size they are, says Aki. That very well might be the reason why. They're so small. There are bugs today that do get pretty big. But some of them rely on crypsis to defend themselves. Like these giant stick insects. They can avoid predation by looking like a stick. Yeah. Pretty cool, right? More like a branch, says Claire. Fair. Yeah. Where's that photo? But yeah, they get really, really big, some of these giant stick insects. Just enormous. So yeah, it wouldn't surprise me if predation is what is keeping these critters small. Like, if they get too big, they just get eaten by other animals. By vertebrates. Yeah. Interesting. Looking like a big stick, I suspect they were also speaking softly. There you go, Gacklin's Wharf. Gacklin's Wharf is on a roll today. These excellent jokes. Anywho, let's give our Wheel of News one more spin here. What have we got? Ooh, some good news here, potentially. Fishing gear can help sea turtles. Well. We were talking earlier about a recent obsession of mine. A giant leatherback sea turtle. Absolutely extraordinary creature. A refugee from the Cretaceous period, still alive in the world's oceans today. I am fascinated by these animals and getting involved in their research and conservation this year. You're going to be hearing a lot more about leatherback turtles in the next weeks and months. Hopefully we'll even be able to show some live on stream IRL. It's kind of a dream of mine, and we'll see if we can do that. But these are creatures who have decreased in population by like 90+%. Just over the past few decades. And one of their biggest threats is bycatch, being caught in fishing gear. That is one of their highest, one of their biggest causes of mortality. One of the things that's killing them off faster than maybe anything else. Let's see if I can find quick little video on that. Bear with me here for just a second. Yeah, being caught in fishing gear is a major, major problem for these animals. And I'm trying to find you a clip from the Canadian Sea Turtle Network talking about this. Search. Take a look at this.
Alcide Arsenault has been fishing for 70 years, but he's never had a day like this. He discovered an endangered leatherback turtle in his lobster traps. He called the Department of Fisheries and Oceans.
So they said, okay, now you're going to lose your trap or lose the turtle. But I said, we don't want to lose the turtle, that's for sure.
3 fisheries officers rushed to his boat off Cape Egmont. The turtle, more than 5 feet long and weighing over 1,000 pounds, was stuck. They managed to cut her free.
Look at that, she went, take off. As soon as they got her loose, it didn't take her long to get down. I said, was the turtle in good condition?
I love his accent too.
Lively, no problem. The turtle, it didn't hurt her at all. So then I smiled. A smile come up my face because, you know, it's something like that you want to protect.
DFO says turtles often die when they get caught in fishing gear. In fact, 2 endangered turtles have been found dead in the waters around PEI this month.
Prince Edward Island.
DFO's Kent McRae says that is what makes this a...
Hang on, Prince Edward Island.
PEI this month.
Is that Sunnyside Trailer Park behind it? What's it called? One from Trailer Park Boys? Is that it behind him?
DFO's Kent McRae says
that's Nova Scotia. Sorry, Jerry Moore. Okay, yeah.
The ending.
For us to get the call from the fishermen, for them to have the survival of the turtle ahead of the recovery of their equipment, this was everything went well. Everything went just as you'd hope.
For Arsenault, well, he's back to fishing. The promise of another day for him and for the freed leatherback.
And the turtle, I hope she's happy wherever she is.
Patrick Fowler, CBC News, Cape Egmont.
Beautiful. Here's the link to that. Let's add this to the playlist, by the way. There we go. How new fishing tech can reduce bycatch of turtles and other creatures. Shark Geek might be interested in this too, because I'm sure it applies to sharks also. And Casey Snowart would be interested in this as well. She says finding a way to work with fishermen on safe netting so we can decrease or eliminate bycatch is so crucial. I agree. One of the most important challenges of our time when it comes to ocean conservation. Specially equipped nets can help save some species while allowing fishermen to still catch others. Our oceans are full of sophisticated, perfect traps. Nets, hooks, fishing lines. Designed to capture animals destined for our dinner tables, they often catch other wildlife, too. This accidental harvest is known as bycatch, and every year it causes the deaths of millions of marine animals, including whales, dolphins, sharks, turtles, and seabirds. Nets and gear can asphyxiate animals or cause fatal injuries. Even when the animals are tossed back into the sea, they frequently die. Bycatch is also a dilemma for fishermen. Entangled creatures can destroy equipment, costing time, money, and fisheries' reputations. Over the decades, conservationists, researchers, and fishermen have developed ways to minimize various kinds of bycatch in different fishing stocks around the world. But putting these solutions to work is often a challenge, and many mitigation strategies are never widely implemented. Some approaches, however, have a proven success rate, and more may be on the horizon. Recent research has explored nets equipped with lights. Even low-tech tricks like kitting out gear with plastic water bottles shows promise of reducing some kinds of bycatch, while also being practical for fishermen to use. Because here's the thing, is you can come up with surefire ways of reducing bycatch, but if nobody uses it, then what good is it going to be, you know? You need something that can be easily implemented, something that's not too inconvenient, something that's durable, something that's portable. There's a lot of boxes that you gotta tick in order to really make something workable like this. Despite the challenges, researchers are hopeful. There are not very many conservation issues that I'm aware of where industry and conservationists and consumers and the fishermen and the resource users
all want the same thing, says marine biologist Matthew Savoca, research scientist at Stanford's University Hopkins Marine Station. Every stakeholder wants less bycatch. Keeping turtles out. The bycatch problem has always existed. It's a conflict that's intrinsic to the whole idea of fishing, says marine scientist Nancy Knowlton, a marine biologist emerita at the Smithsonian's Natural History Museum. If you have something that's designed to catch animals, you're going to wind up, almost always, catching some things that you didn't mean to catch. Yet, mitigation measures can make a difference, without significantly reducing the catch of the target species, says Cheng Huang, an expert in sustainability ecology at South China Normal University. Huang and colleagues recently assessed 42 different bycatch prevention measures, reported in 121 case studies, and found that they generally do reduce bycatch of vulnerable marine species. But there isn't a one-size-fits-all solution. Bycatch is a multi-species, multi-gear, and multi-scale problem, says Huang. Expecting a single technical fix to work everywhere is unrealistic. Sea turtles, many species of which are endangered, are among the animals harmed by bycatch, and one of the success stories. We've talked about this on stream over the past couple weeks. In the 1970s, populations of these animals were threatened by shrimp fisheries in waters off the southeast U.S. Researchers started working with commercial fisheries to develop turtle excluder devices that provide an escape route for the turtles and other marine animals after they entered the wide mouth of the trawl nets. So these TEDs, as they're called, they work like this. It's pretty simple, where there's just like a metal bar here with these, well, a metal fence almost, inside the net. And if you're too big to fit through the slats of it, you just get shot up through the top of the net and you can escape. So all the shrimp pass through the bars of the fence, the excluder device. And turtles who are too big, they get pushed out through the top of the net. It's a pretty simple, elegantly simple, beautiful kind of device like this, you know? It's something that just works. It's really cool. Seems cheap and effective, says Dirt or Bust. And if you want to learn more about this, there's a few videos that you can watch, but also I'd really love to recommend a book to you. I've got it right up here. Carl Safina's Voyage of the Turtle talks about this in depth and how much of a fight it was to get these things into wider use, because at first most of the fishermen were vehemently opposed to this. Like, the people proposing this were getting death threats and stuff from the fishermen, and finally some laws went into effect requiring this kind of a device. And then the fishermen decided, like, holy cow, we actually really like this? Because it keeps our nets from getting broken by turtles, by trash, by all kinds of stuff like that. You know? When you're getting your nets destroyed because there's an old truck tire floating there in the water column, when that wrecks your net and you have to go home for the day, like, that's lousy. But in this, if you catch a truck tire in your net, it just gets shot out by the excluder device. So now the fishermen love this. So, it's interesting. Again, that book talks about this story in depth. Anyhow. Turtle excluder devices. Here, I kind of want to... Well, no, we don't have time. I would show you a video of it working, but... You know what? I can't resist. Let's do it. Let's do it. It is really cool how these things work. So there's a sea turtle caught in this net as it's being dragged along by a fishing vessel. then it comes up on the excluder device. See those bars there? The bars are at an angle like this. So they kind of force out the turtle. That looks like a green or a hawksbill there. Could have been a loggerhead. Not a leatherback for sure. But anyway, you could also almost call it a turtle extruder device. Because here it is extruding a turtle from the net. Who is this? It might be a loggerhead. Yeah, look how big that head is. This is definitely a loggerhead. Caretta. Yeah. And there you go, up to the surface. PC says, I wonder if these could work for vaquita. So these are usually for like shrimp trawl nets, not the kind of like gill nets that you have in the Sea of Cortez. Gill nets pose a lot of other problems. Gill nets are more like horizontal. They just string them along the bottom, and like anything that swims into it gets killed. That's kind of the whole point of a gill net. But I'll take another look at a video here from the turtle excluder device. That's a green sea turtle.
When fishers put out their trawl nets in the Gulf of Mexico and South Atlantic, sea turtles often end up trapped in the nets unintentionally.
Yeah.
If the turtles cannot escape, they will drown. This is a major threat to marine turtles, and it is known as bycatch. In the 1980s and 1990s, NOAA and the shrimp industry developed turtle excluder devices. These devices direct turtles toward an opening in the shrimp net so they can escape.
There we go.
Each year, NOAA tests new and improved turtle excluder device designs using loggerhead turtles.
Imagine being, well, one of the researchers or one of the turtles in these experiments. It's like, here you are in this big cordoned off area. I don't know if we're in a pool or what, but
so they can escape.
Yeah.
Each year, NOAA tests new and improved turtle excluder.
Gotta catch the turtles. You can put it back in.
Using loggerhead turtles raised in its Galveston, Texas lab.
Huh.
The required use of turtle excluder devices.
Iacane says turtle tag is the game I never knew I wanted to play. There you go. Yeah.
Has resulted in an almost 100% reduction in turtle deaths due to shrimp nets.
Yes.
NOAA continues to work with fishing industries all around the world to develop new techniques for preventing turtle bycatch and promoting sustainable fishing.
Good stuff. There's a link to that video right there. Let's save that to the Leatherbacks playlist as well. Good stuff. Anywho, researchers started working with commercial fisheries to develop turtle excluder devices that provide an escape route for turtles and other marine animals. This works for dolphins, it works for seals and sea lions, it works for ocean sunfish. Works for anybody who's too big to fit through the slats on the excluder device. After many iterations and eventually regulations, the device became widely adopted, and the current designs are 97% effective. The devices also save fishermen time and money, preventing the loss of shrimp to fish and hungry turtles. Yet still, turtles are threatened by multiple types of fishing gear. Estimates suggest that more than 250,000 of the creatures die as bycatch each year. Gill nets, pictured here, which hang like curtains in the water, or bottom long lines, which string baited hooks held in place by weights along the seafloor, can be especially dangerous for the animals. But attaching green LED lights, or UV lights, to gill nets in the water seems to deter turtles from the deadly traps. In one early test of the idea, researchers compared UV illuminated gill nets to non-illuminated gill nets in Baja California, Mexico, and found that the lighted nets reduced turtle bycatch by 40%. It's pretty encouraging. Lighted nets have since been tested for multiple species in fisheries worldwide. A study in the waters of northern Peru's Sakura Bay, for example, showed a turtle bycatch reduction of more than 60%, thanks to the LED illuminated nets. But they still have yet to be implemented in fisheries on a large scale. Barriers include cost and the perception that lights might reduce the target fish catch, says marine conservation scientist Jesse Senko at Arizona State University. Part of the expense is batteries for the lights, which need to be replaced often. Senko and his colleagues, after consulting with local fishers, designed solar-powered lights that can regularly flash and tested the approach in a coastal gillnet fishery that catches yellowtail amberjack in the Gulf of California, Mexico. They attached lights to 28 gillnets, each paired with a gillnet with deactivated lights as controls, so doing a real scientific experiment. For 650 hours in the area known for high levels of turtle bycatch. The nets with lights reduced expected turtle bycatch by 63% while maintaining target fish catch, the researchers reported in Conservation Letters in October 2025. So it seems like there's kind of no downside to that. Yeah. Yeah, there you go, Casey, right? Yeah. The lights didn't only reduce power consumption, they also worked as buoys, making them easily integrated into the fishing gear. This is crucial for adoption of the new techniques, says Senko. All of a sudden, the light was more or less just part of their gear, he says. It wasn't some foreign thing on their net, it was just another buoy that happened to flash green light. Here's images of that right here. Nice. Probably also helps other fishers avoid those nets and stuff. You're not going to tear through it through propeller if you know it's there. Really cool. Pingers and plastic bottles. Another bycatch prevention method that's demonstrated some success is pingers. Devices attached to the fishing gear that emit sounds that deter echolocating whales and dolphins. This might be good for your vaquita there, Casey. Sorry, our vaquita. Although if you want to learn more about the vaquita, you should go follow Casey Snowart, everybody. Can we get a shout out for Casey? A field trial of these devices in Norwegian fisheries using gill nets, for example, showed that the pingers reduced bycatch of harbor porpoise by 94%. A team reported in Fisheries Research in 2023. But pingers can have their downsides. An analysis of pinger effectiveness in waters off the United Kingdom, where they've been used for more than a decade, found that while they were linked to a reduction in bycatch of porpoises, like the vaquita, who live in the Gulf of California, Sea of Cortez, the pingers were also linked with an increase in bycatch of seals, which seemed to associate the sound with a potential meal. It's like a dinner bell effect, says policy specialist Sarah Dolman of the Environmental Investigation Agency, a London-based nonprofit that campaigns for environmental issues. Pingers that transmit at frequencies outside of pinnipeds, seals and sea lions' hearing range and are thus considered seal-safe have been developed, but the devices can be expensive, especially for artisanal fishermen who tend to use lower-tech gear and may lack supportive government policies and investments. That's kind of the issue with the vaquita right now, so yeah. Some of those small-scale fisheries may reduce bycatch by echolocating animals with a low-tech approach, fixing plastic water bottles to their nets. Detecting thin, fine nets is difficult for dolphins, porpoises, and other echolocators, but water bottles are a more easily detectable obstacle that could help them avoid the net. A preliminary study conducted in Brazil found that by using plastic bottles on nets, they were effective at reducing the bycatch of the Franciscana dolphins, a threatened river dolphin species. It's a realistic option, says Dolman, in places where fishermen don't have the funds to buy and maintain pingers. Practicalities, along with cost, often prevent implementation of bycatch prevention measures, even those that work. Many solutions that get developed and tested never end up being widespread. I guess, yeah, because it's got to be cheap, durable, easy to use. Yeah, cheap, durable, and easy to use. We're very good at providing funding for scientists to conduct trials to reduce bycatch, but very rarely do these trials then continue to the whole of the fleet, says Dolman. Yeah. For a solution to work on a large scale, a number of conditions must be met, says marine sustainability scientist Lakeelia Jenkins of Arizona State. Policies and regulations need to be in place, and they need to be enforced. Perhaps just as important, the preventive measures need to be practical for fishermen to not add extra time and money to the job. The smaller the change, the more it feels like their traditional fishing practices, the more likely they're going to adopt it, Jenkins says. The human side of this issue also needs to be acknowledged. Emotionally, fishermen around the world are beat up and beat down, Jenkins says. This is important to remember, and I think it's something that a lot of people forget. I need to remember this, you know? We say, you're the problem. You're catching sea turtles and whales. You're the bad guy. Again, that's really easy for people like me to say. People who... I don't eat seafood, you know? I gotta remember not to demonize the people who are trying to feed their families through these fishing practices, you know? Instead, fishermen should be empowered and included in the discussions and the development of solutions. The weight of saving the world's oceans, Jenkins says, can't fall solely on their shoulders. Here's a link to this piece right here. Important stuff. And there we go. We managed to get through a good number of different pieces of news today. How many? 1, 2, 3, 4, 5, 6. Not too shabby. We may continue this tomorrow. More fossil and natural history and conservation news. We'll see. But love the wheel, says Casey. Well, let's see. Maybe what we'll start with tomorrow if we do this again. What have we got here? Ooh, more turtles, maybe? Turtles chomped to survive the KPG extinction, the one that wiped out the non-avian dinosaurs. If we do fossil news tomorrow, maybe we'll start with that one. And if you'd like to hear about that, you should tune in then. But for right now, we're gonna wrap up our stream, and let's put a Smilodon under our credits here. And let's see who else is live on Twitch right now. Apparently Casey isn't. I hope your computer troubles are swiftly resolved, Casey. And how are you feeling, by the way, too? I know you were worried that you were getting sick. I hope you're feeling okay. Who else is maybe doing some science or science-adjacent stuff on Twitch right now? Shark Geek is on. Let's go right into Shark Geek, speaking of marine conservation. Good stuff. Thank you to everybody being named in our credits. From new followers and raiders, to subscribers, and gifters, and cheerers, and resubscribers, and re-gifters, those people who receive a gift sub and then pay it forward. I appreciate that more than you know. It's the reason I can continue to do this full time, is because of the financial support of viewers like you. Thank you. Likewise to our moderators, who keep this a safe and welcoming community for everybody. I couldn't do this without you, mods. Thank you for all of your time and effort, dedication. It's I'm honored to be able to do this, and really proud to have you on my team. Thank you, mods. We'll be doing some more paleontologizing tomorrow, so I hope you'll join me again for that. But for now, we're going to go right into Shark Geek, who is surely talking about ocean conservation right now, so we'll go see what he's up to. Anyway, take care, everybody, and we'll see you tomorrow. But right now, hope to see you in Shark Geek's chat. All right. Take care. Bye-bye. See you soon.